Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's learn end-to-end DevSecOps implementation. So typically you will learn what exactly a DevSecOps engineer does within an organization, or if you join an organization as a DevSecOps engineer, what will be your roles and responsibilities? How would you take an application to a production ready state? That is what we will cover in today's video. Now, obviously, when you want to learn something like this, you need a demo application. But you need a demo application that is almost like a real-time application. You need front end, back end, database. Where will you get such application? So don't worry, we will use this demo application in today's video. I created this application and I have the complete source code for the application, which is in a public repository. But before that, let me first walk you through the application. So this is just like any blogging application that you would use on the internet. It can be like Medium, or you can consider this as a lightweight blogging application where this is the front end. Whatever you are seeing on the screen is basically the front end of the application. And within the front end, you have an option to create a new post. And there is a vibe for the post. For example, let's say you want to post something that is trending on the internet. So you can pick up the vibe accordingly. You can just give a title for it. Let's say LLMs, you want to write a very trending topic, or you want to write something very hot, which can get more views for you. So you can just say LLMs are overrated. Let's say this is the title. Author Abhishek. And then you can just keep writing the content. For example, I'll just, to be decided, because I'll work on the content later, let's say, post it. So you can see, the LLMs are overrated is posted. If I go to the website back, so now there are two posts here. If anybody is interested, they can comment on the post. Let's say you make this blogging portal public, which is what we are going to see as well. I'll show you how you can share it with your friends by the end of the video. So they can just come here, they can also leave a comment, they can share their opinion. This way, you can use this as your personal blogging website as well, where every day you can post something and you can even share it on LinkedIn or anything that you do. So this becomes the front end, which is the user interface. Where are these posts getting stored? Like whenever you are creating a post, there is some content that is involved. There are some comments here. All of this will be stored in a database. And what is the bridge between your front end and the database? That's called as a backend. So what I'm trying to tell you here, we will be working on a 3-tier architecture application. This is important because in real time also, you will be working on 3-tier architecture applications. Let's say you join Amazon, their e-commerce platform is a 3-tier architecture application. Let's say you join Walmart, you join even a startup, you'll be working on 3-tier apps. If you're a beginner, I'll simplify this for you. So what is a 3-tier architecture application? There are 3 tiers here. One is called front end, which is the user interface that you see for any website. Even if you look at GitHub, whatever you are seeing here is a user interface, which comes from the GitHub's user interface. Then you have a database. Database is mandatory because end of the day, your data has to be stored. For example, I have created a repository here where I'll be writing some code, I'll be storing some code. So that has to be stored in a database. So database will serve as a storage. And there has to be a bridge between front end and the back end, right? For example, if I'm storing something in the database, how does that get populated in the front end? So there is a layer between front end and back end, which we usually call as back end. So this is one tier, this is second tier, and this is the third tier. That's why we call this as 3-tier architecture applications. Some of you might already know this. If you already know it, it's good. But if you're a beginner, This is what we mean by 3-tier apps. Sometimes you might also come across 2-tier architecture applications, right? You might see some examples on YouTube, on internet. When they say 2-tier architecture applications, that is, there is only front end and back end. There can be some static applications, which is also called 1-tier applications, where there is only front end that is involved. For example, basic HTML pages, right? So you don't want to bother about storing the data. You just want to create a HTML page. Maybe you want to notify something, your basic personal information website or your portfolio website. That can be a front end or a 1-tier application. 2-tier, where you have front end and back end. When you want to make your portfolio website or when you want to make your front end dynamic, you would go with 2-tier architecture applications. And 3-tier, I just explained it to you. Perfect. Now, where will you find the source code of this 3-tier architecture application? Okay, Abhishek, you shared this application, but where will I get the source code? So I open sourced it. Of course, writing such application takes a lot of time. I used LLMs, I used AI to get this application. And now the source code of this application is in this GitHub repository. In general, when you join organization as a DevOps or DevSecOps engineer, your journey starts from this point. So the development team would already have a GitHub repository, unless you are joining an absolute scratch team, someone who is starting the development from absolute scratch. You would ideally get a GitHub repository like this, where they have the source code of the application and they have steps to run the application locally and also some basic information about the application, like in which programming language the application is written, what tech stack is used to build the application, how to run the application locally, if there are any variables, what variables you need to export. All of that information is provided by the development team. So this is where you start your journey, typically as a DevOps or DevSecOps engineer. And what is the end goal? So the end goal, the end goal is huge in this case because we are talking about end-to-end DevSecOps implementation. You should first start with understanding how to run the application locally. Although the steps are steered by the development team, you have to try it by yourself. Only then you know if the steps are correct. Then creating the required infrastructure, because eventually you want to host this application to production. So you need to automate the steps to create the infrastructure. You cannot just go to AWS and create the infrastructure manually, because you might have to do it multiple times across different environments like UAT, staging, production, or sandbox environments, whatever it is. So ideally, as a DevOps engineer, you should automate the infrastructure creation, that is using platforms like Terraform, right? By following infrastructure as code principles. And then, before you deploy the application, you should containerize the application, right? So typically in this case, you have to create Docker files first. Why? Because when you're dealing with microservices, the today's standard is to deploy the microservices as containers. So first, you have to create a Docker file. Then you have to create Docker images. In this case, you have front end, back end, and database. So you have to create 3 different Docker images. And then build the application locally, but this time as containers. Previously also you ran the application, but that was using some manual steps, maybe a shell script that is shared by a developer. But here, after containerizing the application, you have to build and run the application using Docker Compose. So this is your first step of automation for the project. Now in future, if there is a QA engineer that comes to you and asks you, like I want to run this application locally, you can just share the Docker Compose file with them. It doesn't matter if they're using Windows, if they're using Linux, Docker Compose would execute and would bring the application on their local machine. And once this is done, your job is only half done till here. So once you create the Docker Compose file, the next step would be to create Kubernetes manifests. Because end of the day, you want to deploy this blogging site onto a Kubernetes platform. Okay. So even Kubernetes would come under infrastructure creation. So when you create the infrastructure using Terraform, you would create a Kubernetes cluster. But here, at this point, you have to create Kubernetes manifests. Ideally, it is good because it is deployed as a single application. End of the day, you want this blogging platform as one single application. So it is better if you define one single Kubernetes manifest, where once you deploy this Kubernetes manifest using kubectl apply, all the resources that are related to Kubernetes are deployed to the Kubernetes cluster. It can be pods, it can be deployment, service, network policies, it can be storage related components, anything. Don't worry, we will learn all of this. And then once this is done, you also have to implement CI CD, because every time developer creates a commit, every time developer creates a pull request, these steps should be automatically implemented. If not all the steps, at least majority of the steps should be automatically implemented. And most importantly, every action that you perform should be considered with security point of view. Because what we are targeting is DevSecOps implementation. Even if someone asks you to implement DevOps, you should think about security in 2026. So that's why I keep saying, whether it is DevOps or DevSecOps, your end goal has to be the same thing. In every action that you perform, you have to take care of the security. So this is what we are going to implement in today's video. So we will implement all of this step by step. And you don't have to get overwhelmed at any point of time. Understand one thing, I've already implemented DevSecOps for this project, and I have implemented DevSecOps for hundreds of such projects. So if you find it intimidating while I run a command, or if you feel I'm going little fast at any point of time, please don't be intimidated. This comes from experience. Even if you implement DevSecOps for this project and 2 to 3 projects like this, I'll also show you at the end of the video how you can create demo applications for yourself. Once you're done with this, even you will be able to implement DevSecOps at a very easy pace. And also, to make it simple, because I want every one of you to implement this thing after watching the video, what I've done for you, if you head to this project called Jerney, you will find the link in the description. The main branch will have the basic information about the application. But if you switch to a branch called DevOps, here you will have everything that I'm going to implement in the video. So you can see here, I have steps for Kubernetes, I have steps for the Terraform manifest, which is going to create VPC on AWS, which is going to create Kubernetes clusters on AWS. Each and every file is provided. And along with Kubernetes and Terraform, I have Docker implementation, I have security best practices, GitHub Actions implemented, I have Docker Compose implemented. Everything is provided for you. As I told you, after watching the video, I want you to go back, if required, take some time, revise through the manifests in the DevOps branch, and then start implementing the project at your site. If you are stuck, watch the video again, or get to this GitHub repository and look at the manifests. Perfect. So I hope the goal of the video is now clear. What are we going to do? We are going to implement end-to-end DevSecOps on a 3-tier architecture application, because As DevSecOps instance, that is what you're going to deal with when you join a company, mostly 3-tier architecture applications. And what are we going to implement? We are going to implement these steps on the Jerney application, a personal blogging application. But Abhishek, when I join a company, will the README file be this detailed? I'll tell you one thing here. This is a question a lot of people ask me, whenever they want to learn DevSecOps, whenever they want to create a project. This is the first question that they have. Abhishek, I don't understand the code base. Definitely yes. And as a DevOps engineer, it's difficult also because today this application is written in Node.js, React, and the database that is being used is Postgres. Tomorrow you might work on a complete different tech stack. As a developer, you won't be subjected to these many changes because if you are a developer, you learn Java. In the next company as well, you will be working on a Java based application because you would apply for Java based roles. But as a DevOps engineer, the only thing that is constant for you is the change. In one project, you might work on Java application. In another project, you might work on Python application. In another project, you might work on Node.js application. So what you have to rely is on the inputs that are shared by the developer. What kind of inputs? As I told you, the basic tech stack of the application, as you can see here, architecture of the application, project structure, and steps to run the application locally. And yes, developers will share you these steps. If it is a public repository, they would share these steps through the README file for you. But if it is a organizational application, that if it is a private application, they usually have something like Confluence documents, right? Or they usually have this information in Word documents or in the SharePoint documents, whatever is the internal documentation platform that your organization would use. If this information is not shared, which is very, very unlikely, you have complete right to question the developer to share this basic information for you. Only then you can tell them, I can start with the DevSecOps implementation. Let's see what information is provided here. And I wrote this information for you so that it's easy for you to get started. So the architecture of this application, whatever you saw, the Jerney application, the front end is written in React.js and a Nginx web server is used as a reverse proxy. So basically you hit the Nginx reverse proxy, and from the Nginx reverse proxy, request goes to the React application, something like this. So there is a user somewhere. User would access Nginx reverse proxy. So Nginx reverse proxy and front end is hosted within a container or within a pod or a virtual machine, whichever way you would pick up. If you are deploying this on Kubernetes, a pod would have both Nginx and the front end. So what happens here? The user's request would go to the Nginx reverse proxy, and from Nginx reverse proxy, the request would go to the front end, whatever you see here. And this is the general workflow as well, because you can offload the configuration related things, routing related things, security related things. It can be SSL, it can be certificates, or it can be rate limiting. You can do all of that in the Nginx web proxy. So that's why developers choose a proxy server first. And from here, request goes to the front end. So that is what is explained here. Okay. And then the request goes from the front end to the back end. And back end here is written in Node.js, and Express is used for the server purpose. Okay. So again, from the front end, request goes to the back end. And back end here, as I told you, is written in Node.js. What is the functionality of the backend? Very simple. Backend acts as a layer between front end and the database. In this case, we are using Postgres as the database. So every time a user makes the request goes to the front end. Let's say on front end, user clicks on reading a blog. The information related to the blog should be fetched from the database. That is what backend does. Backend talks to the database. Backend gets the information from the database, and the backend forwards that information to the front end. And from front end, request goes to the user. This is how the usual workflow works. Okay, the same architecture is also explained here, along with the ports on which the application is running, because these ports are hard coded within the source code. And this is the clear folder structure. Even this thing will be shared with you. So Jerney is the name of the application, something that I have given. If you want, you can change the name of the application. And it has 3 different folders typically. One is the front end folder, one is the backend folder, and other is the deployment folder. In the front end folder, you have the source code related to the front end. In the backend folder, there is a source code related to backend. And in the deployment folder, there are steps to run this application on an EC2 instance. Ideally, the reason for choosing Linux instructions, because if you're watching this video, you might have a Windows machine. I'm using a Mac OS laptop. A lot of times when I execute the steps, if you try to do the same thing, the execution might fail. So that's why I took an intentional choice to share the steps in the EC2 instance point of view, so that you can also create a Linux machine. I can also create a Linux machine, and we will execute the steps on the Linux machine to bring the application something like this. Perfect. Now you might say, but Abhishek, what about database? No, you don't need any specific source code related to database, because bringing up a Postgres database is just executing one single command. So that's why typically within the application source code, you would find backend folder, you would find front end folder. Okay. So I'm in the DevOps branch. I have to go back to the main branch. Perfect. So this is backend, this is front end, and this is deployment related script. What else? So we learned about architecture, we learned about project structure. These are the steps to run the application on an EC2 instance. Step 1, to create an EC2 instance, basically go with Ubuntu. It is most widely used. Then copy the source code to the Ubuntu instance. If you want to use SCP, you can do it. Or Ubuntu instance usually comes with Git, so you can also use Git. The reason for sharing SCP instruction here, initially I had the source code on my laptop, right? So from the laptop, I copied the source code to the EC2 instance. So I use the SCP command. In your case, it's not the same, because you already have the source code in a Git repository. So you can just run git clone instead of this command. And then you have to SSH to the instance, and then you have to run the deployment script. And this will bring the application live for you. So this is your first step. Just do this and see if you're able to get the application running. But one thing that you also have to do here, in the deployment script, that is setup.sh, make sure you understand what is written. Okay, this is the only thing that is part of the source code that you have to understand. You don't have to understand the backend related files. You don't have to understand how the React application is written. Only thing is focus on the deployment script, which I'll go through for you. Okay, so first of all, what is being done on the EC2 instance? The sudo command is executed so that you get the basic packages, the packages that are required, like git, or update the packages, version related to Python or existing modules on the Linux machine. Then install Node.js. Why are we installing Node.js here, or why developer is asking us to install Node.js? Because the backend is written in Node.js. Then install the Postgres database, then install Nginx, then install Postgres client. run some basic queries to start the Postgres database. And finally, all that you have to do is to set up Nginx configuration, start the Nginx server, and bring the application live. These are all the Postgres related queries that we are executing and Nginx related configuration that we are performing. Let's do that. Okay. So we will head to AWS console. You must have an AWS account. If you don't have, even if you have Azure account, that is also fine. Or if you have a Windows machine, just install WSL. With WSL also, you can get a Linux environment on your machine. Perfect. Launch instance. Let me call the name of the instance as local testing. I'll use the Ubuntu operating system as recommended by the developer. Instance type. T3 micro is very small. If you don't have enough credits on AWS, you can still use it. But if you have some credits, I would recommend at least T3 small for this, because we are running a 3-tier architecture application. Then key value pair. I already have a key value pair. I'm going to use it. In your case, it's up to you. You can create a new one. Allow the application to run on HTTP. Why? If you understand the architecture, you will know the answer. Just go back, and if you notice, developer clearly shared front end is running on port 80, and what we would access is front end only. So that's why we have to expose port 80 on the instance. How do you expose port 80? So there is an option while creating the instance, allow HTTP traffic from the internet. If developer says this port is port 5000, then you have to create a new security group, and you have to enable port 5000 as part of the security group. Okay. Because you're using a Postgres instance, let's say you want to use it, you really want to use it from the EC2 instance. Abhishek, I don't want to continue with the rest of the steps. For me, this initial first step is good enough. I'm just learning DevOps. Then do one thing. Because you are going to use the application from here, just increase the EBS volume size to, let's say, 16 GB. Because your Postgres database is going to use the volume from here. If you create 100 such blocks, or if you create more number of blocks, you would note this storage. Otherwise, you can go with 8 GB storage as well. And most importantly, once you're done with your demo part, delete the EC2 instance, go back to the volumes, that is, go back to EBS, search for EBS or volumes, and check all the volumes are deleted. Otherwise, you will be charged by AWS, not only for instances, but also for the volumes. You don't have to mess up with any of the advanced details. Click on launch instance. Okay, so till now, what are we doing? We are just getting started. We are just running the very first step to understand the application. And this is the most crucial step as well. Before you perform anything, like before you set up the infrastructure with Terraform, containerization, Docker images, this step is very, very important. Why? Because only at this point, you will know the architecture of your application. You will know the project structure. You have to get along this project for 6 months, 1 year when you work in a company. So you should know the in and out of building process, deployment process, and the starting point is running the application locally. Cool. So we have the instance now. Let's access the instance. So we just need the public IP address. I will copy it. I'll go back to my terminal. You can use any terminal. If you're a beginner, you can use the native terminal on your laptop. Even PowerShell works fine if you're using a Windows machine. Otherwise, just go with Mobile Xterm, or WSL also comes with its own terminal. If you have a macOS, go with the terminal. I mean, the name of the terminal itself is terminal or iTerm. Cool. So what are we going to do now? We are going to SSH to the instance. SSH. Let's first switch to the downloads folder. Okay, so I'll just go to downloads. You can go to the temporary directory also or OPT folder also. And I already have the application here. So let me first delete it so that we both are on the same page. The one who is watching the video and the one who is explaining the implementation. rm-rf Jerney, sorry. Okay, now what I'm going to do here, SSH -i followed by the PEM file. I have it in the downloads folder, followed by what is the name of the PEM file? Sample, I guess, or what was the name of the PEM file? Let's see. So go back to the instance. Here I can find, I'll just scroll down, sample key pair. Okay, sample key pair.pem followed by Ubuntu at IP address. If you have just downloaded the PEM file, when you do this, yes, you will run into an error because by default, the one that you downloaded, the PEM file that you downloaded from AWS, they will come with escalated privileges. So what you have to do, you have to run this command, chmod 400, wherever is the location of your PEM file, let's say downloads, followed by the name of the PEM file. Sample, the name of the PEM file, which is sample key pair. Perfect. So run this command and then your SSH command will work. Okay, so we have SSH to the instance. Now, what is the first thing that we have to do? We have to update the apt repositories. Whenever you create an EC2 instance, this is the first step that you have to do. Sudo apt update. But Abhishek, why do we do this? This is a general activity that you perform because the instance that you created, it comes from an operating system, and this operating system might be bundled a long time ago. Okay, and from that time to the time that you're using this instance, there might be some new versions of the packages in your operating system. So that's why you always have to do sudo apt update so that the modules that you have on this instance or packages that you have on this instance are upgraded and up to date. Cool. So now let's use git clone followed by the main branch. Okay, make sure you're on the main branch. You can copy it from here and paste it. github.com, I am Veeramalla, Jerney.git. Perfect. Now let's switch to the Jerney directory. CD, capital J, okay. And there you go. We have all the files that are required. Now we will switch to the deployment directory. Once again, because you just downloaded this or cloned this repository, you have to grant the permissions to the setup.sh. This time, because you are executing the setup.sh, you can grant 700, or if you are confident only you are using this instance virtual machine, you can also go with 777. But the safest option is to go with 700. Setup.sh. Okay, now let's run the script /setup.sh. Abhishek, should I take some time here to understand what exactly is in this setup.sh? Definitely you can do it. The reason why I did not stress a lot, because there are some SQL queries here. If you are a beginner, you might get intimidated with the queries. You might get intimidated with Nginx configuration. That's why I did not go through a lot of it. But if you feel that I can take help from the internet, I have some prior knowledge of Nginx configuration, good enough. Take some time here, pause the video, look at the setup.sh, and once you're good, resume the video. Okay. So what is this script doing? it is executing the packages first, then it will install Nginx, then it will install the Node.js, it will install Postgres. So this might take 2 to 3 minutes of your time. Perfect. So right after 3 minutes, we have the message here. Jerney is now live and you can access it on the local host. I mean, when I say local host, on the EC2 instance IP address. Okay, let's see. We will go back. We will get the instance IP address one more time. This is the one. Copy it, take a new tab on your browser and paste it. Now you should be able to access it because it is running on port 80. Let's see. There you go. So Jerney blog platform, it took I think roughly around 1 second to come up because it has front end, back end and database. For the first time when it loads, it will take that initial 1 second of time. Okay, so you can see here, this is the one that I have running on my local machine at this point, which I'll uninstall in a while. And this is the one we have running on the instance. Here, there are 2 blog posts. Here, there is no blog post because this is a different application which is running on my EC2 instance. This is the application which is running on my laptop. So this way, you can also create an instance of yourself. You can keep blogging here and you can share it with your friends. Okay, now what is the next step? So we are done with the first part to run the application locally. Now it's time to set up infrastructure for this application. Abhishek, why do you need infrastructure? We can just run the application on an EC2 instance. No, that's not how typically it works. Because this is a blogging application, it's fine. I mean, you are the only user, so it is okay. But imagine you are working for companies like Amazon. Okay, even they have front end, back end, database. But every microservice of Amazon is used by millions of users, right? Even at this point, Amazon.com, if you take any single microservice, it would be used by millions of users. Not every application is used by millions of users. There will be some startup, but at least some hundreds of users would be using it. So you cannot rely on this one single virtual machine architecture. These days, the popular architecture is the microservices architecture, right? Even the developer here wrote the application in the microservice architecture. Front end is individually deployed, back end can be individually deployed, right? So for the microservice architecture, the recommended platform is the Kubernetes platform. So our end goal is to deploy this on Kubernetes, right? So we have to set up infrastructure for this. Of course, we cannot directly deploy the application to Kubernetes. There are some prerequisites. First, you have to use Docker to create containers, right? You have to verify the application is working as containers. Then again, you have to define Kubernetes manifests. But all of that comes as next step. First, let's focus on creating the Kubernetes infrastructure. How will we do it? Okay, one way you can do it manually, right? Just head to any cloud platform like AWS, Azure, GCP, and they all have user interface, right? Just go to AWS like this, just like how we created a virtual machine. Similarly, go to EKS, create a Kubernetes cluster by clicking on create cluster. But this is not the recommended approach. What you have to do, you have to follow the standard approach. That is, first you have to create a virtual private cloud in AWS. Okay, what is a virtual private cloud? Virtual private cloud is basically a private network within AWS. Because AWS is a public cloud, you don't want your application to be shared by some other in the world who is also using AWS. So first we will create a VPC, virtual private cloud. We will define subnet for the VPC. First we will define the range for the VPC. What should be the CIDR range? Then we will define a public subnet, a private subnet, and within the private subnet, we will host our EKS cluster. Okay. So this EKS cluster is a managed Kubernetes cluster. We will use EKS Auto Mode. Okay. When you go for EKS Auto Mode, you have both the control plane of Kubernetes and data plane of Kubernetes. All the Kubernetes master node and worker node are managed by AWS themselves. This is the current trend. This is how people are using Kubernetes at this point of time. I mean, mostly. So we will do the same thing with Terraform. Okay. First, we will have Terraform installed on our local machine. You can use your laptop as well. And from the Terraform, we will first connect to AWS, that is using AWS CLI. Okay. And then using this Terraform AWS credentials, we will interact with AWS APIs using Terraform modules. And then using the Terraform module for VPC, we will first create the VPC. Similarly, we will create EKS on AWS. And this EKS, we will use EKS Auto Mode. And once we have this infrastructure, we can go back and follow these steps. So we can go back, create the Dockerfile, create the container, then create Kubernetes manifest, and finally deploy the application onto Kubernetes. And where is DevSecOps here? We are using VPC, which is a secure virtual private cloud. And even while using Terraform, we will follow all the security best practices. I'll show you while creating the Terraform manifest. But I hope this part is clear. Once again, I will repeat this. So what are we going to do now? Instead of manually creating a Kubernetes cluster on these cloud platforms, we will start with using Terraform. So we will install Terraform on our local machine. We will configure AWS credentials with Terraform using AWS CLI. Then we will create VPC using Terraform modules. Then we will create EKS cluster again using Terraform modules. And we will use EKS in the auto mode so that we don't have to bother about upgrades related to control plane, upgrades related to data plane. We can ensure our Kubernetes cluster is always secure with respect to vulnerabilities related to the data plane or control plane. Okay. So again, where will you find the Terraform related code? Switch to the DevOps branch. You can find a folder for Terraform. Click on the folder and you have all the manifests that you are looking for. Cool. So let's start with installing Terraform. You can also use this EC2 instance. For some reason, if your laptop is not well equipped, you can use this EC2 instance. I'm going to use the same thing. First, I look for install Terraform. Okay. So you can search for this. You will find HashiCorp developer. Go to this. And here, look for Terraform installation through the package manager. We are looking for Linux. So, or you can just go for this option here, Linux, sudo apt-get. So we want to install on Ubuntu. So I'll go with this option. Let's start doing it. First thing, again, they are updating the apt repositories. Cool. Once this is done, install HashiCorp's GPG key. This is just to ensure you are downloading the right Terraform package. On internet, there can be some fake Terraform packages. So just to eliminate that, you will use the GPG key. Okay. And you will verify that you are using the right GPG key fingerprint. So even if someone creates a fake HashiCorp website and if they host fake Terraform package, you can eliminate that by using the GPG key fingerprint. Cool. So now add the HashiCorp official repository from where you will be installing Terraform. So we added HashiCorp repository. Because we added a new repository, we will update our apt repositories one more time, because now our apt repositories also has Terraform package in it. By default, it does not have. Like on a Linux machine, if you just go and run sudo apt install Terraform, you will not be successful. Only you will be successful when you add HashiCorp related packages to the apt repositories. Now this command will work. Sudo apt-get install Terraform. So basically for this to work, we executed all the commands before. This is for security best practice. The GPG key, signing off it, verifying it. Otherwise, you can just run this command. This one, add official HashiCorp repository. So just add this one, just run this and run this. In 3 steps also, you can install Terraform, but all the previous steps are for security best practice. Cool. Let's see if Terraform is installed. Looks like it is. Now if I run Terraform version, there you go. So we have Terraform running now. But Abhishek, how do I connect my Terraform to AWS? Right? Because we have to create resources on AWS. Yeah, that is definitely important. How would we do that? So for that, you need to go to your AWS account. In the AWS account, just go to this option here. In the settings, go for account. Okay. So in the account, just scroll down. You have to find security credentials. I think I'm looking at the wrong place. Let me quickly see. So here within security credentials. My bad. Yeah, this keeps happening. When you keep working with different cloud platforms, because I keep working with AWS, Azure, and GCP, sometimes I get confused with the options. Yeah, anyways. So once again, just click on this one to the top right. Then you will find the option for security credentials. Click on it and you have an option to create the access keys. You only have option to create 2 access keys. I already have 2. I'll just delete one. This one is very old. I'll just delete it. Okay. First, I have to deactivate. Sure. Deactivate it and delete it. There you go. Now I'll create a new one. I'm not bothering about hiding the access key, because after completing this video, I'm anyways going to delete these access keys. So this is my access key. This is my secret access key. So I'll run the command Terraform, or first AWS configuration. So AWS configure. Okay. AWS is also not installed. Fair enough. Let's do sudo apt install AWS CLI. So you can see here, we are doing things from absolutely scratch. Okay, once again, AWS CLI is also not out of the box. Let's say AWS CLI download. Okay, we will head to AWS documentation, installing AWS CLI. Install and update. Okay, click on Linux one more time and go for the Ubuntu operating system. So these are the commands. First, we will curl. So we will download the AWS CLI package. Curl is successful. Then let's unzip the AWS CLI. Unzip is also not part. Sudo apt install unzip. There you go. So now we have unzip. Let's proceed with unzipping the package. Okay. So we have all the files inflated now. Now let's run the command sudo .aws/install. Okay. So now we have AWS CLI. Let's rerun the command AWS configure. It will ask for AWS access key ID. Whatever you got here, just copy, paste it. Cool. Now it asks for secret access key. Again, copy, paste it. Default region, go with the region that is nearest to you. Make sure if you are using an EC2 instance, choose the region that is nearest to the EC2 instance, not nearest to you. I created the EC2 instance in US East 1. So I'll also choose the default region as US East 1. Perfect. Default output format. Let's go with JSON. Now, we did the second part of our infrastructure setup. That is, we connected AWS with or Terraform with AWS APIs. Now, if you write the Terraform files, it can connect to AWS APIs and it can create infrastructure on AWS. Cool. How do you write the Terraform files? Okay. See, one way of doing it is obviously you have to learn Terraform first. I made videos on Terraform. We have Terraform Zero to Hero series. It's definitely not possible to cover entire Terraform in this video. So I'll quickly go through the files for you. Okay, I'll explain the steps on how to write these Terraform files, because it's not practically feasible to cover what are modules, to cover what are workspaces, to cover the Terraform lifecycle, entire thing. So I'll go through the files for you. Also the remote backend, state file, there are a lot of concepts. Instead, I'll share my Terraform playlist link in the description. Cool. So we'll go back. So we'll head to the GitHub repository. And in the GitHub repository, these are the Terraform files in the DevOps branch. First of all, you should start writing your Terraform with provider.tf. What is provider.tf? So here Terraform does not understand out of the box if you're creating infrastructure on AWS or if you're creating infrastructure on Azure, if you're creating infrastructure on GCP, DigitalOcean, Oracle Cloud Platform, there are a lot of things, right? So we will define what Terraform wants to talk to in the provider.tf. So this is the file here. Okay. So the provider.tf says AWS is the provider. Okay. I'll go through each and every line for you. So understand carefully. First, we will define the provider configuration. Okay. And then we will define the within the provider. So we said AWS is the provider here. Now, within the AWS provider, what region to choose, right? Because in the AWS cloud platform, there are a lot of regions. In which region the infrastructure has to be created? So you have to define that. Where will you define? You will define in the provider block. Provider AWS, region, we will define this as a variable because I don't want to hard code. If I say US East 1 here, you all will also create the infrastructure in US East 1. Instead, I will variabilize this, just like how we variabilize shell script or Python. Then these are basic tags. Even if you ignore this block, it's fine. Okay, so these are just the blocks. These are just the tags to identify that you created the resources using Terraform. Cool. Once you're done with the provider block, then the next thing that you have to do is to define the variables as much as possible. Okay, you might say, but Abhishek, at this point, I don't know what all variables to create. At least start with defining the variables that you already know. For example, you know the AWS region is going to be a variable. So just say, this is how you define variable in Terraform. Again, we learned this in our Terraform Zero to Hero playlist. So variable AWS region, just provide the description of the variable. What is the type of the variable? Is it a string? Is it a list? Or anything? Then say, what is the default value of the variable? Right? This is one good thing in Terraform. When you define a variable, when you declare a variable, you can also say, what is the default value of the variable? Is it US East 1, AP South 1? So even if someone forgets to provide the variable value here, okay, in the provider.tf, let's say even if someone forgets to initialize, so it will take the default value from variable.tf. Perfect. Then, we are also going to use the environment because as DevSecOps engineer, you will be creating the same infrastructure for UAT environment, staging, production. So another variable for environment. Name of the cluster should also be a variable. End of the day, you are creating a Kubernetes cluster. End of the day, you are creating a VPC. So you also have to provide the names for it, right? VPC comes with the default ID at least, but for the Kubernetes cluster, it's better to provide a name for it. That's what I did here. So the name of the cluster, I'm just calling it as Jerney EKS. Also the version of Kubernetes, I intentionally chose 1.32 here. I can go with 1.34, which is the latest version. I think 1.35. But the reason for choosing 1.32, just to show you how DevOps engineers can mess up with the clusters. If you don't have right security mindset, you can go with an outdated Kubernetes version. I'll show you what happens once we create the cluster. It will show you a clear security banner that you're using an outdated version. Okay, but yeah, the goal here is to define a variable for the cluster version and VPC CIDR range, right? This one here. In the VPC, how many IP addresses do you need? How would you define that? You would define using CIDR range. Every time when you create variables.tf, there will be some level of uncertainty. Initially, you might not know what all variables are required. It is fine. Start with whatever you know. Then it comes to, once you define provider.tf, once you define variables.tf, start writing the main.tf. As the name suggests, main.tf is the main file that you are writing. Cool. Now, we are creating VPC. We are creating EKS. That's what we are doing, right? One good thing about Terraform is that you don't have to write a lot of code. In Terraform, by default, there are something called modules. Okay. In the Terraform modules lecture, I explained very, very detailed what are modules, how to create module, how to use module. But if you want to understand, at least for this video, modules are nothing but the pre-written code, or you can just assume this as pre-written functions, so that you don't have to reinvent the wheel. Let's say you want to create an EKS cluster, okay, using Terraform. You might have to run some 1,000 lines of HCL file, the Terraform files. But this is a very, very common thing, right? Every day, hundreds of people would do the same thing. Create EKS cluster using Terraform within their organization. So why everyone has to write this 1,000 lines of code? Someone can create a boilerplate, or someone can create, how do I say it? Someone can create a function or a module that everyone else can use. That's what Terraform does. So Terraform has modules for EKS, it has module for VPC, it has modules for S3, DynamoDB, whatnot. Terraform has thousands of modules, not only for AWS, for other cloud platforms as well. All that we have to do, we have to use these modules, right? And we just have to pass the values to it. That is what is the basic difference, right? I will be creating an EKS cluster. X person in the Y organization will also be creating EKS cluster. A person in B organization would also be creating an EKS cluster. The difference is primarily, I would use different values. Probably name of my EKS cluster is different. Version of my EKS cluster is different, right? Or availability zones of my EKS cluster are different, but rest of the things are same. That is what we will do. We will use the VPC module. We will pass some values. We will use the EKS module. We will pass some values, right? I'll show you here. So the same thing. First, I'm using the VPC module. Where am I getting this VPC module? Where is the boilerplate coming from? It is coming from Terraform AWS modules, VPC AWS. So I'm using a trusted source. In fact, you can find a lot of modules on the internet, but not everything can be trusted, right? Just like how you can find a lot of Docker images on the internet, you cannot trust everything. but at least Terraform AWS modules are the official modules. You can believe them. And then I'm passing the variables, as I told you. I'm passing the name of the VPC. I'm passing the CIDR range for the VPC. Where did I get them from? I got them from the variables here, right? I initialize the variables, so I'm using them here. And similarly, I'm just adding some default things for the module. For example, enabling the NAT gateway for VPC. I need it. Why? Because I'm using Kubernetes cluster in the private subnet. So obviously my Kubernetes cluster has to communicate with external resources. So that is needed. And then I'm also enabling, the single NAT gateway. I'm enabling here and I'm saying a single NAT gateway so that it is cost effective. And these are some basic tags. What is the tag for private subnet? What is the tag for public subnet? If you don't need, you can avoid this as well. Overall, instead of writing 100 lines for creating a VPC, we just wrote 17 to 30, just 10 lines of code, 10 lines of HCL file. That is the benefit of modules. Then EKS module, again, will not be passing huge details, just the source of the EKS module, version of the EKS module, what is the name of the cluster, what is the name of the cluster version. Similarly, some cluster compute configuration, the VPC in which the EKS cluster has to be, the subnets in which EKS cluster has to be, authentication mode, what are the log types that you need, basic information. Abhishek, where will you get this information also? See, one thing is you can go to the Terraform documentation, but this also comes with practice. Okay, if you go to Terraform documentation, you will find a lot of fields, but you only need to take what are mandatory for you or what are important for you. These are the important fields that you have to take for minimum EKS cluster configuration. I've used the minimum configuration that is needed. You can also use the same configuration and you can explain the same thing in the interviews as well. We used this configuration for EKS. Now, finally, you have to pass the actual variables, right? Here you only declared, but you did not define. Okay. I mean, you just defined the variable name. You did not declare the variable, right? You did not say what is the actual value of it. You said this is the default value, but what if we want to pass a value for the variable? What is your actual AWS region? You can do that using Terraform TF-vars. So in the TF-vars, whatever variables you took, you assign the actual values to the variable. AWS region is a variable that you define. Here you say the actual value of it. Environment, okay, you are saying this is a dev cluster. Name of the cluster, you are saying Jerney EKS. Cluster version, you are saying 1.32. VPC CIDR, you are saying the value. These values here can override the default values that you have in the variables.tf. Right? What is the difference between variable.tf and Terraform TF-vars? In variables.tf, you initially define the variables. You define the default value of them. But in the Terraform.tf, you actually provide the values for the variables. And whatever you provide here, this will override the default values in the variables.tf. Perfect. And then the outputs.tf, whatever you want to see on the screen. Once your Terraform execution is complete, you have two options. One is you can go to the cloud platform. You can see what is the cluster that is created, what is the name of the cluster that is created, is it created with the right name? You can do it from the user interface. If if you want to do it through the CLI, you can define something called outputs.tf. Okay. In the outputs.tf, you can say print the cluster name on the screen. Once Terraform execution is complete, print the cluster endpoint, print the cluster certification authority, print the VPC ID, print the region of the VPC as well as the cluster. Cool. So now let's proceed with the execution. Here on this machine, on the EC2 instance, we have the basic setup ready. It is connected to the AWS environment also. So what I'm going to do here, I'll just go back in the Jerney folder. I will switch git checkout DevOps branch. Okay. You have to check out to the DevOps branch because only here you have the Terraform code. Then let's switch to the Terraform. Okay. This is the Terraform files. These are the ones. Start with Terraform init. There you go. So the basic Terraform initialization is going on. What is the basic Terraform initialization? Which provider it has to connect to? What is the provider configuration? Right? If there is any backend where you want to store your state file, right? All that configuration is done during the initialization. If you look at my provider.tf, there is also something called backend configuration, which we learned in our DevSecOps configuration or the playlist. How you can secure Terraform state file by using a backend. So right now, the Terraform state file, which holds the information of everything that you created using Terraform, will be stored on this machine. But if you don't want to store that on this machine, you can define a backend configuration so that your Terraform state file will be created within that S3 bucket. Cool. Now, before you execute, just run Terraform plan. Terraform plan will show you what all the configuration that will be created. Only if you're confident with Terraform plan, you can run the Terraform apply. It will say, okay, if you execute this Terraform files, 57 new resources will be created. Don't worry about the number, but Abhishek, why are 57 resources being created? I'm only creating VPC and EKS. There will be internal resources, right? Within VPC, you have subnets. Within subnets, you have routes, route tables, you have NAT gateway, you have endpoints, then you have a lot of internal VPC components and Kubernetes related components. That's why it is saying 57 components will be created. Again, you can pause the video here if you're executing parallelly. Just go ahead and see what are all the resources that are being created. It will be very interesting for you. And also, it will be very insightful. Cool. Now, I'm confident with this because I wrote the Terraform script. So I'll just say Terraform apply. Okay. You don't have to be confident with the script that I've written. Just look at all the resources that are being created. Only then run Terraform apply. Cool. Now, this would take a lot of time. In fact, this can take up to 30 minutes as well. So what you can do while this is getting executed, you can go back, watch the video one more time, or you can look at the Terraform repository. Make sure you enter the value as yes. Otherwise, it will keep waiting. Click on yes. You will have roughly at least 15 minutes of time. Terraform execution is complete. It is successful. And even on the AWS console, I can see Jerney EKS cluster. And importantly, status of the cluster is active and the version of Kubernetes is 1.32. But let's perform an additional check by deploying a simple resource to this cluster. One thing that you have to note, the banner here, end of standard support for Kubernetes version 1.32. So this is what I was talking about. While going through the Kubernetes version in the Terraform manifest, I told you I intentionally picked up 1.32 to show you that what happens when you pick up an older version. So right now, from March 23, this version is going to be out of support. So let's say there is some issue with this Kubernetes version, AWS will not take the responsibility. So as DevSecOps instance, it is also important whenever you are dealing with Kubernetes, even Python packages, Terraform, make sure you use the up-to-date version. Otherwise, let's say this Kubernetes cluster is created in production. Today, there is no issue, but after 13 days, this will go out of support. Cool. So now, how do we connect this EKS cluster to our personal machine or AWS EC2 instance and deploy a sample pod onto this cluster? So for that, what you have to do, again, either take your terminal or take EC2 instance, it's up to you. The first thing that you have to do is use the AWS CLI command, AWS EKS update kubeconfig. So this is the command followed by --name, the name of the cluster, in this case, Jerney EKS, --region, US East 1. Now this will update the kubeconfig configuration on your local machine. Again, for EC2 instance, whatever you're using. But one thing is that you have to have kubectl running on the machine. I already have kubectl running. Now I updated the kubeconfig. So if I just do kubectl get pods-a, I will get all the pods that are running on the cluster. Right now, there is nothing running on the cluster. Even if I do kubectl get nodes, you would see there are no nodes on the cluster. But Abhishek, why is the case? We created the Kubernetes cluster using Terraform. Why are there no nodes on the Kubernetes cluster? If you remember, we created the cluster using EKS Auto Mode. What happens in the EKS Auto Mode? So EKS Auto Mode is just like serverless. And this is also managed control plane as well as data plane. So only if you create a pod on the Kubernetes cluster, or you create series of pods on the Kubernetes cluster, according to your requirement, EKS Auto Mode is going to spin up servers for you or worker nodes for you. This is taken care by Carpenter. You don't have to install anything. By default, EKS Auto Mode comes up with Carpenter. Carpenter is the one. It looks at the incoming pods and creates or sets up nodes to the EKS Auto Mode cluster depending upon the load. I'll show you. Now we will create a deployment. kubectl create deployment. Let's say name of the deployment is nginx --image nginx latest. Now, as soon as you do this, you will notice a node will be created for you. So initially, when you go to the resources, you would see the pod in the pending status. Click on the pod, look at the description. You will see no nodes available to schedule this pod. This is where Carpenter is working. Now Carpenter will get a status update that, okay, there is some scheduling that is taking place, but there are no nodes on the Kubernetes cluster. So let me create one. In next 2 minutes, you will have a node that is set up and the pod in the running state. Yeah, there is one downside of it. This will take little time because the nodes are not created out of the box. If you go to a usual Kubernetes cluster, it's not the case, right? Usually when you create an EKS cluster, you would set up node pool by yourself, where you might create 3-node cluster, 6-node worker node cluster. So as soon as you create a pod, one of the node will be picked up by the scheduler and pod is automatically scheduled on the node. But in this case, this is very, very cost effective. So that's why it will only create the node for you when you request for a pod. Let's see. I think this should be 2 minutes. I'll refresh the status. There you go. Now it is in the running status. This is exactly how EKS Auto Mode works. Even if I do kubectl get nodes, now you should see one node that is set up for you. If you create 100 nginx pods, then it might create 10 Kubernetes nodes for you, right? Okay. So this part of verification is also done. So till now, what did we do? So we are done with the first step, setting up the application locally. Then we are done with infrastructure setup as well. That is using Terraform. We are successful with this step. Now let's go to the next step, containerization of the microservices. This is where a lot of DevOps engineers get scared. Personally, I've seen a lot of them worry about creating Docker files. Why? Because I keep hearing, Abhishek, to write the Docker file, do I need to know programming or do I need to know how the application is written? Let me tell you, this is absolutely not required. Because as DevOps engineers, you will keep working on different programming language applications. Today, you might have to containerize a Node.js application. Tomorrow, you might have to containerize a Java application, .NET application. The list can just keep going on. Unlike developers, right? Because developers, today, if they work on a skill set, in the next company, most likely they'll work on the same programming language. So what you need to do as a DevOps engineer, you only need to learn the structure of the Docker file. If you know the structure of the Docker file, creating Docker file is a cakewalk because every time you do exactly the same steps. I'll explain you the structure here. Just remember, then for the front end, for the back end, we will follow the same structure. The first thing that you have to do is use a base image. Okay, this is the first step. How will you pick up the base image? Just go with the programming language that is used by the developers. In our case, React or NPM, that is part of Node. So we will use Node as a base image. If you are working with the Java application, you can use OpenJDK as the base image. If you are working with Python application, you can use Python Slim as your base image. The second step, choose a work directory. It's just like choosing a directory on your laptop, but in the Docker file, you choose a work directory so that all the commands that you're going to execute next, they will be executed within the particular directory. Let's say to download a file from the internet. If you choose a work directory, you are sure that the file is downloaded within a particular location. That's why you use the work directory. Okay. Then the next thing. Once you choose the work directory, go ahead, copy the dependencies. Again, if you are using a Python application, copy the requirements.txt. If you are working with Java application, copy pom.xml. If you are working with, let's say Go application, copy go.mod. In this case, we will copy package.json. Okay. Then execute the dependencies or install the dependencies. You copied them. Now you install. Then copy rest of the source code files, typically all the files. And then you will build the application, right? These are the steps that you need to follow. You have to do it step by step because Docker caches in terms of layers. And once you do this, this is where you can actually end. You can use an entry point and you can execute the build. But what we are following in this lecture is DevSecOps practices. So from security point of view, what we will do, we will go with multi-stage Docker build. So in the multi-stage Docker build process, we will use this as the first stage. And in the second stage, which you can also call as production stage, what we will do, we will again choose a base image, but this time we will go with a lightweight base image, or we will go with, if you are dealing with front end, we will go with Nginx base image. Why? In case of front end, Nginx receives the request and Nginx forwards the request to the front end, right? We already learned that during the theory part. User's request goes to Nginx and Nginx forwards the request to the front end so that it can block certain requests, it can proxy the request, it can implement SSL for your front end, it can implement DDoS attack prevention, anything, even web application firewall. So we will use Nginx as the base image for front end, and we can use any other base image like a distroless or lightweight base image for the backend. And then we will copy the artifact that we got in the first step. So when you run the build command, you would get something in the dist folder if you are working in the Node.js application. If you are working with, let's say, Java application, you get a jar file here, right? If you are working with, let's say, Golang application, you get a self-contained binary. In the production stage, just copy this binary here and use the non-root user, another good DevSecOps practice, so that you don't run your container as a root user. And finally, use the entry point or CMD. That's it. So this way, you will not have your source code, you will not have the dependencies and any unwanted things in the production stage or in the second stage of your Docker build. They are all part of your build stage of the Docker file. In the production stage, you will have a lightweight image so that there will be very less security issues potentially. You will copy the artifact that you got from the first stage. You will use a non-root user, another important security practice. And using command line or entry point, you will execute the binary. This is the process that we are going to follow. If you remember this process, any Docker file you can write effectively. And now we will do the same process for our front end first. I'll take my Visual Studio Code so that it is easy to write instead of using the terminal. I clone the repository here. I'll head to the front end folder. I'll go to the SRC, and within the SRC, I'll start writing the Docker file. So I'll create a file here, new. Let me call this as Dockerfile. Or, I mean, there is no hard requirement that you only have to put it within the SRC. If you want, you can also put it at the parent level. For example, within the front end, just create a new file and call it as Dockerfile. This is also good enough. Okay, so let's start writing the Docker file. As I told you, the first step is going to be from, we will use a base image. In this case, Node is the base image. Choose a version of Node. I'll go with 20 Alpine. You can also get this from Docker Hub. If you're not sure, Abhishek, how do I get the Node.js base image? Just go to Docker Hub and here search for Node. Okay. And you will notice, so this is the official Node images, Docker official image. Click on it. And here you have all the versions. Abhishek, why did you go with 20? Because the latest version is 25. Very simple. I am intentionally taking an older version so that our CI/CD pipeline will break. I want to show you how an DevSecOps pipeline looks like. So we cannot take a perfect application. We want an application that is flawed. We want an application that breaks on our DevSecOps pipeline. That's why I'm using an older version. If you want to go with a perfectly executing CI/CD pipeline, then choose the latest version. I'll provide an alias to it as build. Cool. Then the next step, as I told you, go with the work directory. We'll choose /app as a work directory. Then we will copy the package.json. So use the copy package.json, and in some cases, you also have to go with package.json star. Okay, this is not required for every front-end application. At times, when you have package.json log file, or when you have similar files, you would go with this. And where you want to copy? You want to copy it to the work directory. So just say dot. And then the next step is to execute the dependencies. How would you do that? Run npm CI. And also you can just do npm cache clean -- force. Abhishek, how do you know these commands? That these are the commands that you have to use? These are actually provided in the setup.json as well. If you go to deployment folder, if you look at setup.json, to run the application locally, almost the same steps are followed. Okay. So you can either follow the instructions from here, or when you are initially writing the Docker file, you can also ask the developer. Cool. Now let's copy the rest of the files. Copy everything to the app folder and run the build process. npm run build. Right? The same thing that I explained here. I followed the exact same instructions. You give me a Golang application, I'll follow the same steps. You give me a Python application, I'll follow the same steps. Okay. Now, because we want to build a DevSecOps architecture. We want to do everything secure. Let me call this as final stage, or you can also call it as production stage. And this one, let's just leave a comment here for easy understanding for others that this is the build stage. Abhishek, is it common to have only two stages? Yeah, usually you have only two stages, but it doesn't matter according to your application. Let's say you are dealing with a complex service where you are building the front end, back end as part of the same microservice. In fact, you can go ahead and you can create multiple stages as well. Okay. So there is no hard limit that you only have to have two stages in a Dockerfile, in a multi-stage Dockerfile. Okay, because we are dealing with front end application, we will use Nginx as the base image. Nginx :27 hyphen Alpine. Again, you can get this from Docker Hub. As production. What is this as? This is basically a alias we are giving to this stage. Cool. Now, usually when you use Nginx as the base image, it's a security best practice to remove any kind of existing Nginx configuration, because we are going to place our application within the Nginx folder or our artifact within the Nginx folder. So that's why I'm removing the default one. I mean, if you have used Nginx in the past, when you install Nginx, by default, if you run the Nginx web server, you see index.html, where you see something like hello from Nginx, the out of the box one. We are just deleting that one here because we don't want to see that. Instead, we want to see our application served by Nginx. Cool. But Abhishek, where is our Nginx configuration? It is already here. If you look at the front end, you will find nginx.conf file here that is initially written by the developer while they are working on the local development of the application. So just copy that. Copy nginx.conf, which is here, to the nginx location on the Docker image. /etc/nginx conf.d default.conf. This is where you have to place. Now it's the final step. I mean, the important step. This particular command in the build stage would have created a binary. Basically, that is in the /app/dist folder. So we will copy /app/dist, the content of the dist folder, to user nginx html folder. Okay. That is the most important step, where we are copying the output of our first stage to the final stage. Now what happens? The front-end application is in this particular location. User share nginx html. Now, if this is in this location, what nginx does, instead of serving the default index.html, it will serve your front-end application. Cool. So this part is clear, right? We are copying the artifact from the first stage to the final stage, where we are placing our front-end application in this particular location. When you place front-end in this location, user requests Nginx, Nginx automatically forwards the request to the front-end. And for security best practice, let's create a user and let's grant permissions to the user. So I'm creating a user called Nginx. I mean, in the Nginx base image, the user is available out of the box. So for the Nginx user and Nginx group, I'm granting permissions to the Nginx HTML folder. And we will say go with the user Nginx so that the container runs with the Nginx user instead of the root user. There are several disadvantages when you run your container with a root user. Basically, I'll give you one example. I've covered that in detail in our DevSecOps playlist. But if you run your container as the root user, anyone who gets access to the container, if your container gets hacked, potentially they can get access to your entire system. If you are running it on Kubernetes, they can get access to your entire Kubernetes cluster as well. So it is not a good practice to go with the root user. Let's expose the port. Expose port 8080 or whatever is the right port. And in the CMD, we will just say Nginx, right? We are running Nginx -G. So basically I'm starting Nginx here. Daemon off. Okay. So this is our final step. Now we are good to go. Nginx -G daemon off. So this is the Docker file for your front end. If you master this particular example, trust me, tomorrow you work with any front-end application, you will be confident. Even in the interview, if they ask you to write a Docker file, you can write the same Docker file because we followed security best practices and also we wrote a perfect Docker file for the front-end application. We will execute this, okay, and quickly verify if this is working. So I'll go to the folder. So the folder name here, my bad. So let me go to Jerney first. And here, let me go to front end. We have the Docker file here. Let me see if my VS Code is syncing right. Okay. So they are perfectly synced. Now you need to have Docker running on this machine. If you are going with an Ubuntu instance, Docker should be available out of the box. You can use the Docker. If you are using your personal machine, just start Docker. So I'll run this command, Docker build -t front end. I'll just call it as front end. Yeah, I think it's okay. Colon latest dot. So basically, I'm creating the Docker image with this particular tag, front end latest, or let's say Jerney front end. Even simple way of understanding. Let's see what happens. It's okay if there is any issue, we will immediately try to address it. Nginx failed to resolve metadata. So it says, Abhishek, you are using a wrong base image. This one does not exist. Maybe there can be some typo here. Oh yeah, there you go. So there is a simple typo. It's not Nginx 27, it's 1.27. How did you figure out? You can go to the Docker Hub here. In the Docker Hub, search for Nginx. You will find the official Docker image for Nginx. Click on it. You will find set of tags. What we are using is 1.27, right? But Abhishek, why are you going with, again, not the latest version? As I told you, we want to see some issues with the Docker image. That's why I'm using an older version. Cool. As part of DevSecOps, we want to identify some issues. That's why we are intentionally using old versions. Let's rerun this. Oh, is it not saved? Again, it says the same thing. Maybe I did not save it well. Vim Dockerfile, or let me go back to my VS Code. It's easy to address there. 1.27. This is cool. It's updated here. Nginx 1.27 Alpine Node 20. Okay. So let me do it one more time. Docker build. I'll just change the tag of the image in case if it is caching the information. Cool. So that part of the Docker image went ahead. That part of the execution moved ahead. Now it is complaining about the package.json. Okay, this is fair enough. If you see the files here, there is only package.json. There is no package.json star. That's why it is saying I could not find package.json.star. That's a simple thing to fix. In fact, you will not run into this issue. Personally, why am I running into this issue? Because I used EC2 instance for the running the application locally to just show you. And here I'm using my personal machine. The reason for using personal machine is simple. I want to show you how to write the Docker file using VS Code. So that's why I'm just using my local machine for the next steps. Cool. How this can be fixed? If you just run npm install, it will generate the package log.json. So I executed npm install. Now, in the front end folder, I have package log Package.json as well. Now let's retry. I'll run the Docker command again. This time I guess it should pass. Okay, looks like it is going well. So it is executing the last step of the first stage, run npm CI and run npm build. And then it also executed the production stage. It says, now we have the Docker image ready. Cool. So the front end Docker image is ready. Now it's time to go with the backend Docker image. Again, I'll go to the backend folder now. So this is the backend folder. I'll click on create a new file and Dockerfile. Okay. So let's start writing. It will be the same thing. As I told you, we'll follow the same architecture of the writing Dockerfile. So this one here, whatever I showed you. First, base image. Second step, work directory. Third step, copy the dependency files. Fourth step, install the dependencies. Fifth step, copy rest of the files. Sixth step, execute. I mean, in all the applications, it is not possible to execute, but if there is a chance, execute it and then go with the final stage. Okay, so we will start writing the backend one. I'll go back to VS Code. First, base image from node:20 hyphen alpine. We'll give an alias to this as well as build. Abhishek, why did you choose the same base image for front end as well as back end? When you're working with JavaScript based applications, it's most likely you're using the front end, back end, everything in the JavaScript family, where you would use npm as your dependency manager. So that's why we are using Node as the base image. Okay, let's say you're using JavaScript for front end like React and you're using Python for your backend. Let's say you're doing that. Then in the Python backend, you have to change this base image. This would become Python. Next step, work directory. You can go with /app. Next step, copy the package.json. Along with that, copy any similar entries like package-log.json and anything else to the dot. That is this particular directory, the /app. Then we will install the dependencies, run npm CI. Okay. And again, npm clean cache --force ampersand this one. Cool. So we are installing the CI dependencies. We are using npm class clean --force. And for npm CI, if you are working with the application in production environment, go with --only production. What exactly this is doing? So sometimes you might have dependencies related to production, dependencies related to dev, staging. So just say --production. And for the backend, especially in this case, you don't have to copy the rest of the files and create the backend at this point. What you can directly do, you can go with the production stage itself. So *production stage, where I'm just providing an alias to the production using node alpine image. But Abhishek, why are you not executing the dependencies here? In our case, why are you not installing the application by building it? We don't have to build the backend because our backend is very, very lightweight. We can directly execute the backend in the production stage itself. Instead of creating the backend build in this stage and copying it to the production stage, if it is lightweight, you can directly do it in the production stage itself. Okay. So we will create a user and a group. Last time we did not do it because we used the Nginx base image. In the Nginx base image, we already have something called Nginx user. So we did not bother about it. Right now, we want to follow DevSecOps practice. We want to run the container as an on-root user. So I'm just creating a user in this Docker image. And then we will install the required dependencies. Then we will create a work directory. In this case, /app is a work directory. We will copy the source code along with node modules. Where did you get the node modules? You ran the dependencies here. So we are copying the dependencies. The node modules, in the case of node family, the dependencies are called node modules. So we are copying it to the final stage along with the source code. We will use the app user, the one that we just created here, to run the container. So non-root user called app user. We will expose the port, expose 5000. And finally, in the entry point as well as CMD, we will directly execute the JS image, src index.js. I hope you understood this point. Why are we not running the npm build command in the first stage? Because we just have a single index.js file, very lightweight one. It doesn't make sense. You create the binary here, then you copy it here. If you just have to run this single command, you can directly do it in the production stage itself. Okay, cool. So this is our backend. Let's try to verify this is also working fine. Intentionally, I did some security mistakes in this Dockerfile, using the old image here as well, and even the dump init, the package that we are installing. This should also come with a specific version like 21, 22. We should not be using latest because the behavior keeps changing on every Docker execution. Let's say today the dump init version is 20. Tomorrow it is 21. Day after it is 22. Every time you build a Docker image, there will be the difference in the behavior. So always you have to pin the versions, pin the images to a particular version, just like how we did here. So I did 3 intentional mistakes in this Dockerfile so that our DevSecOps pipeline, the one that we are going to build, will fail on the Dockerfile. Cool. Okay, so I'll go back to the terminal. Docker build -t. Let me call this as backend colon latest dot. Oh, my bad. I have to switch to the backend folder. Let me do that and rerun docker build -t backend colon latest dot. Okay, let's verify. Yeah, so the build execution is complete. We have Dockerfile for frontend and Docker image for frontend and Docker image for backend as well. Abhishek, what about database? You don't need to create Docker images for databases because databases Docker images are already available in Docker Hub. For example, we are using Postgres. So just search for Postgres. You will find the PostgreSQL official Docker images. You can go ahead and use them, right? Why you have to do things from the scratch? You don't want to get the Postgres source code. You don't want to create a Docker image for it. Instead, use that is already available. Okay, so we created. Let's go back to our status. Where exactly are we in? So we ran the application locally. We created the infrastructure. We created the Docker files. We created Docker image for front end, back end as well. For DB, it's not required. We will use the one that is available. Now it is time to create a Docker Compose file. But Abhishek, why is Docker Compose needed? Very simple. When you are working with multiple microservices for a company or for a project in the company, it is a good practice to create a Docker Compose file. Why? Individually, in this case, we have 3 containers, right? What if you have 10 containers? Or what if you have 5 containers? Every time there is a change in the Docker file, every time you want to build a new version of your application, you cannot keep running 10 different Docker files, right? And in fact, once the Docker images are created through the Docker file, in this case, we created the front-end image, we created the back-end image, and we are using a DB image. But how will they interact with each other, right? How will you make sure they are all in the same network. How will you make sure front end can connect to the back end can connect to the database through the password, right? Your database will have a password, right? So you have to provide the password as an environment variable, or you have to provide the password through some configuration. What I'm trying to say here, just by creating the containers, your job is not done. Your responsibility is to make sure they all come up as a project. All the images talk to each other. They are within the same network. They have the volume requirements. They have the environment variable requirements. So all of that you can do using Docker Compose file. It is a one single file that helps you run multiple Docker images in the order of dependencies and with every setting and configuration that is required. Who has to write the Docker file? Docker Compose file? You have to do it. Just like how you created the Docker files, you have to create Docker Compose file as well. Is it complicated? Not at all. There is a simple structure for the Docker Compose file. I'll write it again for you. So to explain it in the easy way, so the structure of the Docker Compose file, you will start with services. What are services? Front end, back end, database, the microservices. So under the services, just start with, let's say, front end service. Okay. You will provide the configuration of the front end service. You can just say either provide the Docker image directly, or just say from where it can build the Docker image. So just provide the path of the Docker file. Along with that, any environment variables that you want to pass. For example, the API tokens, passwords, secrets, anything that you want to pass, and any volumes that you want to deal with. Once you're done with the front end, similarly, create under the services. This is basically a YAML file. Under the services object, you created front end. In the same way, create one for the backend. Again, either provide the image directly or provide the location of the Docker file. Then the environment variable, the password to connect to the database, etc. Finally, DB. Okay. So even for the DB, you will provide the configuration. And then at the services level, you will create a network. If you want to create a new network, you will create a network for all of these containers. If you want to create any volumes, at the services level, you will also create volumes that are required. That's it. If you do this, your Docker Compose file is ready. And when you execute Docker Compose using Docker Compose up, this is the command to run. Once you run Docker Compose up, all the containers will be started and your project will be running on your local machine. This is very, very beneficial for QA engineers, developers. If they ask you, Abhishek, I want to set up this project on my laptop, just tell them install Docker, execute this Docker Compose file using Docker Compose up, and you will have everything running on your machine. You don't need to know Docker. You don't need to know how to run, how to read a Docker file. You don't need to know anything related to Docker. Just install Docker and run this command, Docker Compose up. That's the beauty of Docker Compose. Cool. So how will we write the Docker Compose file? So in this main branch, you can just create a Docker Compose file at the parent level folder, right? That is at the root of the repository here. So we will have to create a Docker Compose file. Okay. So here, let's create a new file, docker-compose.yml or YAML. It's up to you. Let's start. So we will start with the services. As I told you, what microservices are we dealing with? We'll first deal with the database microservice. So DB. For database microservice, we are directly using the image. We are not using the Docker file, right? So let's just say Postgres. What is the Docker image that we are using? Column 16 -alpine. I'm using an older version again for the same reason. But if you want, you can just go with the latest version. Okay. And then the name of the container. If you want a name for the container that is created, you can just say container name. I'll just say Jerney-db. So Docker Compose file can also create the images for you. Just like how we did by running docker build -t, right? You don't have to do it when you have Docker Compose. It can not only start the containers, but it can also build the images for you. Right? In this case, I'm just providing the image name directly. If I provide the Docker file here, it will create the image. What we will do for front end and back end, let's give the Docker file. Although we created them already, but just to show you, for front end and back end, I'll give the Docker file to Docker Compose. But for database, I'll directly provide it with the image. Cool. So image name, container, and there is also a cool feature of Docker Compose. For some reason, if your container goes down, you can say restart the container. So unless stopped for some reason, do not restart. So if my container goes down, maybe because of resources, because of CPU, memory, anything, just restart the container. This is a cool feature, the one that you get with Kubernetes as well. Then the environment variables. Definitely we need environment variables for the database. So I'll just say the Postgres username, Postgres password, and the Postgres DB. Why you need this? Obviously, you are starting the database container. So the database container will have the Postgres instance, and the Postgres instance should be created with some schemas, or it should be created with some tables. For all of that, you need a database user, database password, and name of the DB that it has to connect to. Then the ports, we usually have only one single port when you're dealing with database. So what you can do, you can map the port of the database that is running within the container to the port of your local host. How can you do that? Let's say the port is 5432, which is the default Postgres port. We will map it with port 5432 on my local machine as well. Again, you are dealing with database. So you also need volumes. So volumes only for database, the number of steps are usually more. So volumes, just provide the volume mount. So PG data is the volume that I am mounting to this specific location within the container. But Abhishek, where will you create this volume? Like you haven't created the volume called PG data. We will do it. After the services definition is complete, what I'm going to do at the same level here, I'm also going to create something like this. Volumes, PG data, driver as local. When you add these fields in the Docker Compose file, it is exactly same as Docker volume creation command using your Docker CLI, right? Docker Compose file will not do anything extra. It will do only things that are supported by Docker CLI. But only thing is that we are not running the Docker CLI commands. We are putting them in the YAML manifest so that all the commands can be executed at once. This one here is running the container for you. This one here is creating the volume for you. Similarly, I will add another container for front end, another container for back end. All the steps will be executed in the same order. Okay? Unless you maintain the dependencies. If you want, you can also add some health checks. So I'm going to add the health check here to just make sure the database container is started and everything is good. This is optional only if you want. Now, similarly, let's go with another service. So I'm going with the backend service now. I'm done with database. I'll start with the backend service. So here at the same level, I'll just say backend. And as I told you for backend, instead of directly using the Docker image that we created locally, I'll provide the build context. I'll say build context. I'll provide the location of the Docker file. It's in the backend folder. right? Docker Compose is here. This is the backend folder. Inside the backend folder, there is the Docker file. So I'm just providing the path of it. Okay. Then also say the name of the Docker file, because in this folder, it has to know what is the name of your Docker file. I'll say the same name, Docker file. If you have a different name, you can go with it. Then just say here, let me just fix the indentation a bit. Okay. So next thing, the name of the container underscore name. I'll just call it as Jerney underscore backend. I'm following the same nomenclature. I'm calling the database name as JerneyDB. I'm calling the backend container name as Jerney underscore backend. What next? We'll follow the same practice, restarting the container unless stopped. Okay. Environment variables. Even this time, we have to pass the database related environment variables because backend will connect to the database. So I'm saying environment 5000 DB username, DB password, everything that is required. Expose the port. So eventually backend should be connected to the front end. So I'll expose the backend on the port 5000. And Docker Compose should first start the DB container. Only then it should start the backend container. So I'll use this depends on tag. Something like this. Depends underscore on colon DB. Now this says backend container will only be started once the DB container is ready. And also I'll just say there is a condition. Not only DB container is started, but the condition is that DB container should also be healthy. So service underscore healthy. I hope this is clear. The depends on tag says that only start the DB container once database is completely ready. And because you are providing a condition also, it will wait till the service is all good. And some security related steps here. So security, where I'm saying no escalated privileges are required. Just run the backend container with the user that is provided in the Docker file. Now finally front end. Okay. So even for the front end, we will use the same thing, name of the service. I hope the indentation is correct. Yeah. Here for YAML, you have to be little careful with the indentation. Front end, of course, I can write this entire file using some plugins in Visual Studio Code. I can write it by taking help of GitHub Copilot, but I'm intentionally writing it so that you also understand what steps are involved. Build, either provide the container image or just say context dot slash front end folder. Docker file is here. What is the name of the Docker file? The name of the Docker file is with the same thing, Docker file itself. Name of the container, let's call this as Jerney underscore front end. This should be the name of my container, or hyphen. Did we follow hyphen or did we follow underscore? Let me see that. Okay. So here we used hyphen, container name Jerney hyphen DB. Here we used underscore. Let's follow the same standard. Jerney hyphen backend, Jerney hyphen DB, and Jerney hyphen frontend. Restart policy, only unless stopped. Then port mapping. What ports do we want to map while running this container? Frontend is running on port 80. Right? So I'll just say 80, 80, 80. So this is the internal port mapping. So port mapping of the application running inside the container and my local machine. Okay, this is also well indented. All good. Now, depends on. Is there any dependency for front end? As you can guess, a front end without backend doesn't make sense because everything that we are seeing here, all the information should be populated from the database. It should be populated from, the logs that are created. It should come from database, and backend should fetch it from the database. So your order of starting the containers, you should first start database, then you should start backend, and only then you should start the front end. So that's why depends on backend, where backend is internally dependent on the database. Just provide the security option one more time in the front end as well, so that your front end does not run with escalated permissions. There you go. Your Docker Compose file is ready. That's it. So this is how you write the Docker Compose file. When you look at it initially, you might feel that, oh, this is a 66 line YAML file, but we just wrote it in 10 minutes. And there is no additional thing here. The same fields that you have to follow, the services field, which will have the list of microservices. And each microservice has the same fields. Within the DB, image, container image, restart, environment, ports, volumes, health check only if needed, and any security related thing. Even in the backend, build, container name, restart, environment, expose, depends on security settings. Same in the front end as well. So this is where people ask me the question, do I need to learn Docker Compose file? Do I need to learn Dockerfile? Will I be asked in the interview to write Docker Compose, to write Dockerfile? Answer is simple. Just remember the structure. See, nobody is a superhuman. Nobody can remember everything. But if you remember the syntax, if you remember the fields that are part of important fields that are part of Docker Compose, Dockerfile, Kubernetes manifest, that is good enough. Explain them. This is how I'm going to write the structure of the Docker file, and you will definitely clear the interview. Cool. Now let's verify by running this Docker Compose as well. What should this Docker Compose do for us? Step one, it has to build the Docker file for front end and back end to create Docker images. Okay, even before that, it has to pull the database related Docker image, and then it has to build the Docker files for front end and back end. It will first start with the database as per our order that we provided. So once the database image is pulled, then it will start the database container with all the settings that we have provided, the environment variables, the security settings, the health check settings. And once the health check is successful, then it will go to the backend service. And in the backend service, as I told you, it will first build the Docker image. Then it will configure the environment variables. It will see if it can connect to the database. And if it can connect to the database successfully, again, it will start with the front end. Cool. Now it will create the front end image and it will verify if front end can interact with the backend. That's all. This is what Docker Compose is going to do. How can we run Docker Compose? Take the terminal. At the same location of the Docker Compose file, we are not there. It is somewhere here. Okay, this is the location of the Docker Compose. At the same location, just execute this Docker Compose YAML file. What is the command to do it? Docker Compose up. Let's do it. So going back, if you already have images that you created using Docker Compose, you can do this Docker Compose down. So first Docker Compose down is going to delete everything for you. Of course, I ran this application previously, so that's why I ran Docker Compose down. Now I'll run Docker Compose up -d. -d will start these containers in the background, and you will not see the logs of the container when they are starting. Okay, so it is taking time to pull the Jerney DB container, but otherwise, rest of them, because there is some Docker caching on my machine, previously executed it. That's why it was very, very fast. Now let's verify. Okay, Abhishek, you ran the Docker Compose as well. Now let's try to see if on my local machine, I can access the application. Okay, so all the containers are started, the front end, back end, database, everything is configured, everything is connected to each other. So let's verify if the application is running through the Docker Compose. On which port should we access it? Front end is running on port 80. So you can see here, we expose the front end port to 80. So we will request the front end. So request goes to the front end container. From there, request goes to the backend container. From there, request goes to DB container. We don't have to bother about it. We will head to the local host. I'll take a new tab, local host. I'll not provide any port because the port is 80 and click on the enter. There you go. So we have the application running on port 80. Okay, how is that possible? That is possible through Docker Compose. Now, if I click on anything, for example, new post. So we got these emojis, we got this basic information. This is coming from the backend. So this is coming from the database and backend fetch this information for us. So overall, the Docker Compose part is also successful. Where are we right now? Let's go back to our initial stage, the one that we documented, the list of steps. We are done with the application running locally, infrastructure, Dockerfile, Docker images, Docker Compose, Kubernetes cluster creation. Now, only thing that we are left with is Kubernetes manifest creation, which is not going to take a lot of time, and CI/CD pipeline setup. Okay, let's even take a look at them step by step. Let's start by listing down the Kubernetes manifests, right? So what all resources that we have to create in Kubernetes? From Docker Compose, it's clear what we have to create. We are done with it. But for Kubernetes, we have to create few more resources, starting with, okay, let's start with the obvious resources that we have to create. So there is front end, there is back end, there is database. For database, deploying database to Kubernetes requires dedicated resources. First, you can create the deployment instance. So for database, you can either go with deployment or you can go with stateful set according to your requirement. In this case, deployment is fine enough. But along with that, you can just not create the deployment for the database, but along with that, database also needs a volume, right? It needs a persistent volume. How can you create that? So with deployment, you have to create a persistent volume claim and you have to create a storage class. This is how you create a database within the Kubernetes cluster. You have to create either deployment or stateful set. Then you have to create a persistent volume claim that is going to create a persistent volume for us. But for that, persistent volume claim looks for a storage class. Let's try to understand what is a storage class resource. Let's say you are creating this on EKS, the way which we are doing. On EKS cluster, you have volumes like EBS, right? EFS, AWS, FSx solutions. Which one is your Kubernetes pod going to use? In this case, which one is the Postgres going to use? You have to provide that information. So you can say, I need 10 GB of volume, but do you need EBS volume? Do you need EFS volume? Do you need FSx volume? That is defined by the storage class. So as DevOps engineers, whenever you are dealing with databases in your organization, just first create a storage class in the Kubernetes cluster. That will tell any database deployment that it has to get the volume from these particular options. If your storage class is EBS, then persistent volume claim, if someone creates a persistent volume claim of 10 GB, right? The persistent volume claim asks the storage class creates a EBS volume of 10 GB. Similarly, if someone creates 20 GB, same thing. EBS volume of 20 GB is created. Now, once the deployment related things for database is done, you have the front end. So for the front end, you will create a deployment, right? Plus you will create a service. For the backend, again, you will create a deployment and you will create a service. But we want to do it in the DevSecOps way. right? So we want to secure everything as much as possible. So for the backend deployment, let's say this is front end, this is backend. So for the backend, we will create a network policy as well. Network policy in Kubernetes creates an admission controller. Anyone who tries to connect to the backend, network policy first intercepts the request and it will see if it should allow the request to backend or not. But Abhishek, why do we need a network policy? Very simple. Your backend should only be accessed by the front end. Why should your backend be accessed by the hacker, let's say, or some other pod in the Kubernetes cluster? That should not be the case. So we will create a network policy and we will only accept the request if the request is coming from the front end. In the same way, even for database, we will create a network policy. Any guesses? Who should access the database? It should be backend. So in the network policy for DB, we will say allow only requests from backend. For front end, it is not required because front end is exposed to the internet. You don't have to do anything. And then for the backend, we will also create a secret. Secret so that it can sensitively connect to the database. So the database credentials are stored within the secret. These are the resources that we are going to create. Let me list down here one more time. So for the front end, we will just create deployment. Then we will create SVC. This is for front end. For the backend, we will create deployment. We will create SVC. We will create database secret. This can be for database instance as well. Plus we will create a network policy. For database, we will create a deployment. We will create SVC. We will create persistent volume claim. We will create storage class as well. So these are overall resources that we are going to create. I might have missed one or two. I think I haven't missed, but if I miss one or two while creating the Kubernetes manifest, we can recollect that. But overall, these are the important services, resources. Now you have two options. One, individually you can create YAML file for each of them. But because we are doing the demo, it will be little difficult to create like almost 11 resources. So what I'll do, I'll create a single YAML file. Okay, it will be easy to deploy as well. I'll create a single YAML file and I will call this as Jerney.YAML file. Okay, in the Jerney.YAML file, we will have all of these resources. So it is going to be a very huge YAML file, but that's okay. Okay, so I'll go back to my VS Code now. I'll close all the tabs. I'll just maybe create a folder called K8s here. You don't have to do it in the main branch. Okay, in my case, I'm just showing you by creating this in the main branch, but during your learning process, you know where all these manifests are. Once again, if you head to the DevOps branch, in the DevOps branch, you can find all of them in place. I created this branch for you. CI/CD is also running. Kubernetes manifests are in the working state. Docker files are in the working state. Docker Compose is in the working state. This is your blueprint. At any point, if you're stuck, head to the DevOps branch, look at the manifests here. And once you're comfortable, do the project without looking at these manifests. Cool. So Jerney.YAML. I think I just messed up a bit. Let me move this to trash, and inside this, let me create a new file, Jerney.YAML. Okay, perfect. So now you can start in any order. In Kubernetes, it does not matter. If you are following health check, you can follow any order. So I'll start with creating the resources. First thing, I'll create a namespace. Okay, this is one thing that I forgot. To create a namespace, I'll use this syntax. Okay. So API version is v1, kind is namespace, and I'm just providing some basic metadata, the label for the namespace and the name of the namespace. Then we will create a secret for the database password. Okay. So this is the one that I'm creating, the database secret. This has the database username. This has the database password. Cool. So this is also fine. Next thing. But Abhishek, how did you get this database username, database password? We already have that, right? If you look at Docker Compose file, we have the database username, we have the database password. Just encode this in the base64 format and paste it here, or just copy it from here as well. Okay. Then, as I told you, you have to start with creating a storage class. So for storage class, we will be using the EBS storage class, which is very easy. When you use EBS storage class, as I explained here, if you create a persistent volume claim for the database, the persistent volume claim will talk to the storage class, and storage class within your Kubernetes will create EBS volume with the required size. And this is the storage class YAML manifest. Name of the storage class, I'm saying it should be EBS volume. Type should be GP3. In EBS, you have GP2, GP3 types. So I'm saying GP3 is the type. And I'm just saying reclaim policy as retain. Cool. Then comes persistent volume claim. Before creating the database related deployment, I'm creating persistent volume claim and storage class as well. And if you notice here, I'm saying my database would need 10 GB of EBS volume. Cool. Now the actual database deployment. So for the database deployment, we will use the Postgres official image. Because it has health checks also, you might find the database manifest a little big, but in the spec, we are saying the replica count is 1. We are following the rollout strategy, and then we are defining here. So this is going to be the container. Name of the container is Postgres. We are using the same image, the one that we used in Docker Compose, Postgres 16 Alpine. The container port is 5432. We created a secret file. We are using the secret reference in the deployment so that it can access username, password. And this is the volume mount for the storage class that we created. So 10 GB of EBS volume will be mounted in this particular location. We did in fact same thing with Docker Compose as well, but in the Docker Compose, we created a local volume. Whereas in the Kubernetes manifest, we are using EBS volume. Okay, then now we are done with the Postgres database deployment. Let's create a service for Postgres. This is the one. So in the service, I'm just saying the target port is 5432 and the port the service should be accessible is also on 5432. This is perfect. Now let's head to the backend deployment. Labels are important. Okay, I'm not focusing a lot on the labels, but take some time, look at these manifests, see how I define the labels. It is unique for every resource that I'm going to create. Especially, this is unique for the database deployment, the backend deployment, the front-end deployment, because in Kubernetes, service identification happens through the labels and selectors. Service discovery. Okay, now let's go with the backend deployment. You might have a question here, but Abhishek, when we are dealing with the backend deployment, how did you come up with the image name? Okay, because here we created a Docker Compose image. That is fine, but the image that we created is still on your local machine, right? If I do Docker images here, I have the image, but this is not pushed to the Docker Hub, right? Jerney backend latest or Abhishek F5 Jerney backend latest. This is not pushed to Docker Hub. Yeah, we have to do it. Okay, first of all, we have to define that. What I'm going to do, Jerney frontend latest is the image, right? So this is the one that we created through Docker Compose. I will tag this Docker tag this one as Abhishek F5, which is my Docker Hub username, followed by the same thing. Jerney, we copied for the backend. Sorry, this is the front end. So I'll just say Jerney frontend latest. I already did it because I wanted to, before doing this entire demo, I verified it on my Kubernetes cluster. During that time, I already tagged this image to Abhishek.FI Jerney frontend latest. I tagged this image to Abhishek.FI Jerney backend latest. So both of them are already in my Docker Hub. I'll show you. So this is Docker Hub. Go to Abhishek.FI. Okay. So these are my repositories. Here, if you search for, or directly let's search for Abhishek.FI Jerney frontend, you would find it. See, it is pushed. Okay, and I verified it as well. Similarly, I pushed Jerney backend also. In your case, please execute these commands. First, tag the Docker image. Instead of Abhishek.FI, you should go with your Docker Hub username and then just say Docker push followed by this. In case you run into any authentication issues, first run the Docker login command. I'll repeat this. With Docker Compose, we created the images, but the images are on our local machine. What you ideally need, you need these images to be pushed to the Docker Hub. Only then you can access them within the Kubernetes cluster, right? So first do the Docker login on your machine, then tag this image. The one that you have on your machine now is Jerney backend latest. Tag it to your username / Jerney frontend latest, Jerney backend latest, and then use the Docker push command to push it to Docker Hub. Perfect. Without pushing it to Docker Hub, if you try to run the Kubernetes manifest, you will see the pods are in the error state. Okay, perfect. So now, just like backend, let's copy the front end as well. Okay, my bad. Before that, let's copy the from the GitHub repository. Let's get the backend service configuration. This is the one. Okay, so in the backend service also, what is important? The target port and the port that you're going to use. Then let's copy the front end configuration. Where am I copying it from? I'm copying it from our GitHub repository itself. Okay, this is my front end deployment configuration. Okay, so I have the front end deployment configuration. Similarly, front end service configuration as well. How are we going to expose the front end service? Abhishek, end of the day, your Kubernetes cluster is in EKS. It is within a VPC. How are we going to access the front end that is deployed? You have two options. Either you can create an ingress or gateway API, or you can port forward the service. We will go with port forward, right? The service that is created, we will use kubectl port forward command and we will access it. If you want to use ingress or if you want to use load balancer service type, you are free to do it as well. Finally, network policies that I mentioned. This is the important part. This is the DevSecOps part that we are dealing with here. Okay. So, oh my bad. I was copying in the Jerney YAML file. I'll fix it. But the network policies are very important. So the network policy for backend and network policy for database. You have to explain this in the interview. When someone asks, how did you secure your Kubernetes cluster? Network policies is very important. Just say, whenever we are using database, for database resource, we are creating network policy. It uses the admission controller concept and it will only allow requests from the backend pod. Where did you define this in the network policy? If you look carefully, this is a network policy for database. Okay, so network policy is applying for the Jerney DB, which is my database pod, and it is only allowing incoming requests. Ingress means incoming requests from the Jerney backend. It totally depends on the label. And where is this label? This label is on the backend pod. Okay, similarly, network policy for the backend, you can see here, this network policy is applicable for Jerney backend, and it will only allow the request from ingress from Jerney frontend. That's what we did. Cool. So this is about the Kubernetes YAML manifest. Now I'll just execute the kubernetes.yaml, and within few minutes, we should have all the resources on Kubernetes. Let's run the command. So where we have the Kubernetes manifest, I'll just head to the K8s folder and run this command kubectl apply -f Jerney.yaml. So this should set up all the manifests on our EKS. Again, this will take maybe 1 to 2 minutes. It might take more as well because we are using EKS Auto Mode. Every time the pods are created, the resources are created, Carpenter has to scale the cluster. Let's see. I'll refresh the page. The resources should be in the pending status at least. Yeah. So DB has started, but backend resources are still in the pending state. So that's good. It's actually very fast. We have the front end running, we have the back end related components running in the pending state, and we have DB also good. Cool. We'll only select the Jerney namespace. We are not worried about the other ones. There you go. All the resources are in the running state. In fact, it's much faster than I thought. Maybe because I already created a Nginx deployment. So Carpenter created a pod. It created a node for us. It is reusing the same node, I guess. If we do kubectl get nodes. Yeah, so the same node is being reused. The pods that we created, they actually have enough resources on this node. That's why it was faster. If you're doing it for the first time, if you haven't done Nginx deployment, don't worry. This might take up to 5 to 6 minutes as well, because Carpenter has to create an EC2 instance as a node for you. Cool. Okay, now we can verify. Let's see the services. kubectl get svc -n Jerney. I'm only looking for the front end service because this is what I'm going to access. Let me kubectl port forward. kubectl port forward followed by svc. I'll say Jerney -front end. If it goes wrong, we'll fix it. We don't have to worry. Followed by the port is 80. I'll expose a very different port. Let's use 6666 colon 80. So I'm mapping this port of the service to port 6666 on my local host. -n Jerney -address 0.0.0.0. I'm mapping it with the local host. Let's see what happens. Okay, the port forwarding is good on the local host. Let's do this. Localhost colon 6666. Address is restricted. So address uses a network port, which is normally used for the purpose of web browsing. Okay, that's fine. Let's change the port and see. Instead of 6666, I'll use a different one. I used 8172. The same command, I just replaced 6666 with 8172. And this time on port 8172, I can access the application. In fact, this is new to me. I was not aware 6666 port is restricted. Good to know. Anyways, so we have our application running in Kubernetes as well. Please take some time to go through the Kubernetes manifest. While I explained you, it's not that easy. Especially, a lot of people have questions about database, how to deploy database in Kubernetes. Is it possible? It's definitely possible. In fact, it's not a rocket science. You just deploy it as a basic deployment. Only thing is that additionally, you have to create persistent volume claim and you have to create a storage class. Okay. Now, finally, we are only left with one thing. You all know what it is. It is the CI/CD process. But even till now, we considered a lot of security best practices. In fact, in every step we did that. When we started with infrastructure creation, apart from running the application locally. During the infrastructure creation, we did not directly create EKS. We considered security best practice. That is, we created VPC. Okay, let's write it down here. What all security measures did we take till now? One, we created VPC, virtual private cloud. Then we created private subnet. We did not expose Kubernetes API to outside. Okay. This is about infrastructure creation. Then we worked on the Docker files. While working on the Docker file, we used multi-stage build, another security best practice. We ran the containers as non-root users. Then in the Docker Compose as well, we took care of the secrets, right? And then when we were dealing with Kubernetes manifests, we used network policies for security best practice and to make sure DB is not compromised with any other external access. Similarly, backend as well. Yeah, so these are some things that we took care till now. The final thing is CI/CD pipeline. And usually in CI/CD, you can do a lot of things in the CI/CD pipeline, the DevSecOps practices. Let me first tell you what are the things that we are going to consider. Okay, even before writing the CI/CD pipeline. The first thing, when it comes to GitHub Action, when it comes to this pipeline, we are going to use GitHub Actions. Why? GitHub Actions is very, very popular. It is gaining a lot of significance, and especially for public projects, this is the go-to solution. If you are hosting your repository in GitHub, I would say just go with GitHub Actions. It can be GitHub Enterprise or any kind of GitHub installation. Then within the GitHub Actions, we will use multiple stages in our pipeline today. We will start with the basic linting check. Linting check is basically like checking the semantics, syntax related things, verifying if there are any additional spaces or any basic security failures. Then we will look at, then we have a stage called SCA, Software Composition Analysis. This will verify if the dependencies that you used in the application build process, any of the dependency, if it is vulnerable, if there is any CVE attached to it, or if there is any security threat with respect to the dependency version that you used. It can be dependency related to your front end, back end, everything will be covered. After software composition analysis, we will look into another stage where we will build the Docker image. And during the Docker image build stage, we will create the images for front end as well as images for the back end. Once the image is created, we will perform image scanning, where we will go with Trivy, another security best practice. And once this is done, we'll also perform linting on the Docker file, because in the Docker file, you can go with a lot of security inefficiencies, or you can do issues with respect to Docker, not best practices, right? And then I'll use another thing called Checkov. Checkov is for security scanning of the manifests. If you followed our DevSecOps 0 to Hero playlist, all of them are already covered. I'm just taking that extra effort in this end-to-end CI/CD pipeline to cover all the steps in one place. We covered Checkov in our DevSecOps 0 to Hero. We covered image scanning. We covered SCA. We covered linting. But anyways, what Checkov does, it performs security scanning on the DevOps manifests. For example, the Kubernetes manifests, the Terraform manifests. But Abhishek, what can be issues with the manifests? I'll give you a simple example. Let's say using Terraform, you create an S3 bucket. Maybe because you are new to Terraform, you copied the manifest from somewhere. You are creating S3 bucket, but eventually the S3 bucket will be public because of the configuration that you used. Now, if you create this S3 bucket in production, and if you have some information in the S3 bucket, because of your lack of experience, the bucket is public, it is exposed to the hackers. Who can prevent this? Checkov can prevent this. So Checkov will scan your Terraform manifest. It will say, hey, your Terraform manifests are good, but they are not very secure. If you execute them, it will create resources that are not secure. Similarly, it can go through Kubernetes manifests as well. Maybe used latest tag for the image, it will say, hey, latest tag is not good. Go with a particular version. Or you used, maybe you used health check where you did not follow a particular standard. This is where Checkov comes into picture. And then we will update the Kubernetes manifest file. So we created a Kubernetes manifest file, right? When the Docker image is complete and when all of these steps are complete, the Kubernetes manifest should be updated with the new image that is created, right? Developer created a pull request, all these steps are executed, or developer created a commit, all these steps are executed. Obviously, a new version of the Docker image is created. You have to make sure the image is updated in the K8s manifest and then commit the K8s manifest back. This is what we are going to look at using GitHub Actions. Cool. So let's go step by step. There are close to 10 to 11 jobs in the CI/CD pipeline that we are going to write, but that's okay. I already have the workflows here. I'll just delete it for you so that I'll do it from the scratch. Okay. Create a folder called .github. This is the first thing that you do. Within the .github, create a folder called workflows. Okay, let me do it. New folder, workflows. And within this, you can put anything as the name of your workflow file. I'll just call it as ci.yaml, or you can say cicd.yaml, or you can say anything else as well. Cool. What is the first thing that you write in the CI/CD file, GitHub Actions file? Start with the name of the workflow. I'll just call it as Jerney DevSecOps workflow. Cool. Now, on which action the CI/CD should be executed? I'll say execute it on the push action on all the branches in the repository. Okay. If you only want the CI file to execute on a particular branch, you can decide that as well. But I'm saying on all the branches. And then I will say execute it on the pull request as well. And again, pull request on any branch. Branches, colon, star. Good. Okay, this is perfect. Even if someone copies this CI/CD pipeline, because you used star as the branch, it will work for them. Next thing. So the next thing is to define the environment variables. If you're using any environment variable within the GitHub Actions, this is the right place to define it. What I'm going to do, instead of using the Docker registry, see, when we created the Docker compose file, when we created the Docker images through it, even through the Docker file, we got the images locally, we tagged them, and we pushed them to the Docker registry. But in real time, when you work in your company, you might not use the Docker registry. What you might use? You might use GHCR, GitHub Container Registry. So it is a best practice. Any image that is created through CI/CD pipeline, we will also use GitHub Actions Container Registry. For that, you just have to provide 3 variables here. One, name of the Docker registry, ghcr.io, just like docker.io. Name of the backend image, ghcr.io, followed by GitHub repository name. So what will this turn to? ghcr.io, followed by Jerney, which is the name of my repository, followed by Jerney backend. So in this particular location, the backend image will be stored in the GitHub records. Similarly, this is a repository for my front-end image. Cool. So we defined these environment variables. Now the actual thing, jobs. Each thing that we discussed here is basically a job. Linting is a job, SCA is a job, build is a job, scanning, again linting of the manifest files, checkout, update, commit, everything is a job. So you have to define the jobs field in YAML, and you can start with stage 1. You can use something like this to say, now for easy identification, you can use a comment and say, I'm starting with the first stage, that is the lint stage. Basically, when it comes to GitHub Actions, just like Docker Compose file, there is a specific syntax that you will follow. You might write 10, you might write 15, you might write 20, but you will follow this step where the first thing that you do, let's say we are dealing with the linting job, you will provide the name of the job, anything. Then you will say, what is the runner for this? In GitHub Actions, you have two things, right? One is self-hosted runner and one is the runner that you can bring, personal runner. Okay. So if you are using the self-hosted runner, the hosted runner and the self-hosted runner. Hosted runner, let's say you want to go with the GitHub hosted one, you can say Ubuntu latest. So it will spin up a runner for you. And this linting job will run on this virtual machine. You don't have to create it. You just have to say what is the operating system that you need or distribution that you need. And then if you want to continue this job on error, no, in our case, we have 10 different jobs, right? Do you want to fail the entire CI/CD pipeline if this job is failure, or do you want to continue? I want to continue because I know my CI/CD pipeline will fail. So I'll just say continue on error as true. Okay. So this will pass. This will not pass the particular job, but it will move to the next step. And then start with the steps. That's it. So these three are common for all the 11 jobs that we are going to create today. And within the steps, we have the order of the steps to follow. For example, to perform linting, I'll just say what is the name of the step, and I will use a GitHub action uses the checkout action. So checkout action will check out the code for us. Then next step, I will set up again. Every time you create a step, provide a name for it and use the GitHub action. You don't have to write the code. There are hundreds of GitHub actions out there. For example, to set up Node.js, you can use this GitHub action action/setup-node. This will install Node.js on the virtual machine. So this will check out the code. This will install Node.js. Then we will install dependencies, right? And finally, we will run the linting check. Okay, let's put this in action. So first for linting, this is how we are going to write. Okay, so these are the things. Paste it. So linting, name of it, lint code, runs on Ubuntu latest. Strategy matrix for component backend and frontend. That means execute the same thing 2 times. One is within the backend folder and one is within the frontend. For frontend as well as the backend application. What do you need to execute? Within the steps you define that. Check out the code, set up the Node.js, and once the Node.js is set up, install the dependencies and run the linting. Okay, my bad. So here I'll just say install the dependencies and run linting. That's it. This is the first job. Similarly, we'll proceed with the second job. So the second job is to verify software composition analysis to verify if there are any dependency issues. For that, this is the job. Okay, let's take some spaces and this is the one. I'll walk you through them. SCA. So I'm saying name of the software composition testing as dependency audit. Runs on Ubuntu latest. Needs linting. That means only execute this step after this one. I'm just defining the order. Okay. So this will be the first one that is executed. This will be the next one that will be executed. In the strategy, again, front-end and back-end, because we have 2 microservices in the same repository. Instead of writing the same states 2 times, we are saying for front-end and for back-end. And this is a folder name for front-end. This is the folder name for back-end. This will be replaced here. Once for front-end package.json, once for back-end package.json. Okay, so check out the code, set up Node.js, install the dependencies, and perform the auditing on the dependencies. Okay, perform auditing on front-end dependencies and back-end dependencies. How will you do it? Using the npm audit command. If you are using Python, you can use pip audit, right? If you are using Java, you can use a different command. If you are using Go, you just have to change the command. That's it. Okay, next thing, the building of the Docker images. To build the Docker images, these are the steps that we're going to follow. Let me quickly put them here and explain it to you. Because this is huge, if I have to write it, this will take a lot of time. In fact, this might take up to 3 to 4 hours. So instead of that, I'll walk you through the steps. First thing, build is the name of the job. Again, runs on Ubuntu, needs SCA. So I'm defining the order of the jobs to execute. Matrix, front end as well as the back end. So front end Dockerfile and back end Dockerfile. 2 times this will be executed. Check out the code. Set up Docker on the virtual machine. Install Docker. Then log into the GitHub container registry, just like how we do Docker login. Then run the Docker image. Basically create the Docker image, and this should be the name of the Docker image. If the matrix is being executed for front end, the name of the image would be ghcr.io frontend Jerney frontend. This will be the name of the image. If these steps are executed for backend, ghcr.io Jerney followed by Jerney backend. Okay, cool. And then we are just pushing the images to the ghcr.io. Again, for both of the things, front end as well as the back end. Once the Docker images is complete, we have to scan the Docker image, for which we will use Trivy. And these are the steps for Trivy image scanning. Not only Trivy, there are multiple options that you can follow, but Trivy is very, very popular. So the name of the job is image scan, where we are choosing a runner. For every job, you have to choose a runner. Okay. Every time you create a job, you have to go with a runner. This time the runner name is again Ubuntu latest. Steps, check out the code. You must be seeing something. The steps are quite repetitive. Every time we are checking the code, every time we are following the same things like choosing a runner, continuous on error. Yeah, that's what GitHub Actions is all about. That's why I say if you practice 2 to 3 GitHub Actions on 2 to 3 applications, your job is done. You will never forget the GitHub Actions again, at least the structure. And this time we are using Trivy. So this is the action for Trivy, where we just have to provide the image name, Jerney frontend, Jerney backend, and it will perform the scanning. And it will tell you if there are any critical issues, if there are any high severity issues on the image that we created. Okay. Then once the image scanning is done, we will perform security scanning on the manifest. As I told you, using Checkov, you can scan Kubernetes manifest, you can scan Terraform manifest. That is what we are going to do. IaC security scan is the name of it, Ubuntu latest. Check out the source code in the first step, then install Checkov on the virtual machine using this action, Checkov action. And we are providing the location of the directory. First perform on the Terraform directory. Run the Checkov command on the Terraform manifest and let us know if there are any issues. Then run the Checkov on the Kubernetes manifest within the K8s folder and let us know if there are any issues. Okay. Finally, we'll perform Docker linting before we execute the update Kubernetes manifest. What are we going to do in Docker linting? Just like source code linting, we are going to verify if there is any obvious issues in the Docker file. Right? Finally, updating the Kubernetes manifest. Because a new Docker image is created on the developer's pull request, this is what we are going to do. Update K8s manifest. For the K8s manifest, every time the image is created, what we will do, we will head to the Jerney.yaml. We will replace the name of the image here from Abhishek.Fi Jerney frontend, which is currently the name, right? On the repository, this is a current name, Abhishek.Fi Jerney frontend. What we will do, on every action, we will replace the name from Abhishek.FI Jerney backend to the new image ghco.io frontend followed by Jerney frontend and the GitHub commit ID, right? So that every time a new image is created, that is what the script here is doing. I have the script in the GitHub repository. It's basic SCD commands, right? So you can go through the SCD command and understand what I'm doing. So this is the SCD command that is taking the action. Cool. Now let's verify. What I'll do is on the DevOps branch, I will push a dummy commit and I will show you how a new image is being created. And we will also see what are the security vulnerabilities on this application, which we'll identify through DevSecOps pipeline, and also security vulnerabilities in the infrastructure manifests. So all these steps will be executed. All of these actions will be executed on a single commit, and they will tell you if there are any security issues, and also it will update the Kubernetes manifest with the latest image. Perfect. So let's push a dummy change here to the DevOps branch. I will pick up the README file and let's add at the end of the manifest a simple white space. In your case also you can do the same thing, but on your repository. You cannot try it on my repository. Or let me just remove this line. Okay, go back and commit changes. Okay, so the changes are committed. Now the CI/CD pipeline should be automatically triggered. It's just taking some time to refresh, but the commit should be done by now. I don't know, there is some bug in the UI. There was an error. File could not be edited. Let's see why. Okay, I'll do it again. I'll go back, refresh, and okay, I think the issue is with GitHub itself. GitHub is not responding well. Let's try again. In one of the files, go back to Jerney, go back to readme.yaml, sorry, readme.md, edit, and let me update the last line here. Oh, in fact, the commit was successful, is it? No. Okay, remove this line, delete the white spaces, and go up, commit. Let's see. Okay, instantly CI/CD pipeline is triggered. We committed to DevOps branch, so the changes are triggered on the DevOps. I'm keeping the main absolutely clean for you so that you will look at the main branch. It will not have any DevOps manifest for you. You have to work on it from the scratch. If you have any questions, you can refer to the DevOps branch or you can refer to the video. Okay, so here CI/CD pipeline must be in progress. Let's refresh and see. Let's go to the commits. So this is the one that we committed. Remove personal node from readme.md. You can see the 12 jobs are executed. 2 of them are still running, but out of these 12, 2 have already failed and other things have successfully passed. Let's see what failed and what passed so that we get a very clear picture, right? So what all things passed? The first thing that passed is the dependency audit on the front end. So the dependencies that we are using for front end in the package.json, it is saying you are all using the good version. Even for backend, what we used in the package.json, what developer used is absolutely fine. Then in the front end application, linting is good. In the Dockerfile also linting is good. Update Kubernetes manifest. So it is saying the Kubernetes manifest file is updated with the new version of the image. Let's see that. But what failed? IaC security scan failed. So it is saying there is some issue with the, I think it failed for Terraform. Let's see. And even DockerLint has failed. Let's see why DockerLint failed. So it says, see, there you go. I explained this even during writing the Docker file. this will fail. So it says APK add package, the one that you used in the backend Docker file. Okay, you did not provide the version. This is what I was talking about. Okay, I'll go to my this one and explain you. In the backend Docker file, if you remember, I said at this point of time, when you're using APK add dump init, you ideally have to pin it to a version. If not, you are doing a security issue. Tomorrow, by default, this is going to latest, right? If you're not providing anything. So today the latest can be something, tomorrow the latest can be other thing. So every time the Docker image for backend is built, it is different. So there can be a security issue. Today it is fine, tomorrow it can be not good. So that is what the CA also complained here. It said you have to go ahead and fix it. And what else failed? Okay, this is one security failure. And apart from that, another security failure is for Docker linting. Let's see IaC security scan as well. I think we just checked about the Docker linting. Now this is about IaC security scan, where it said, okay, in the Terraform that you used, it did not complain about one mistake, it complained about several mistakes in the Terraform manifest. Assertion error, config parser, we used a list where it is saying you have to go with the string. For which one? If you scroll up, you can find exact reference as well, where exactly it failed. Cool. So this is for Terraform manifest, the Checkov failed. Then what else? The image scanning failed for backend as well as front end. The one that we already expected. Why? We have been using outdated versions in the Docker file. Just to show you, it was an intentional decision. I used Node 20, the image which is vulnerable in the Docker files, both the front end as well as the backend. Node 20 Alpine, Node 20 Alpine. That's why it said, hey, the Trivy said, hey, you are using old versions, so your application is vulnerable to security. So these are the four pipelines, four jobs that failed, and rest of all are successful. Now it is up to you, and it is up to your development team. If someone creates a pull request, do you want to merge, or do you want to ask the developer or DevOps engineer to go back and fix it? Every time someone creates a pull request, this is going to be executed. Of course, here I directly created a commit, but in general, nobody creates a direct commit to the main branch. They would create a pull request. So on the pull request, you will see these things passed, these things failed. Now it is up to you. Do you want to accept or do you want to fail? In fact, if you don't want these jobs to be executed, if you don't want Kubernetes manifest to be updated, you want Kubernetes manifest to be updated with the latest version only if all the other stages are successful, then what you can do, just go back to your GitHub Actions, go back to the CI and remove this line here. For now, we said continue on error true on all the things. Remove continue on error true, and you will notice the failures will stop the further execution. This is also a good practice. This is also a DevSecOps practice where only run the stages if the previous steps are successful. Only run the Docker build if the security scanning and Docker linting is complete. Only update the Kubernetes manifest if rest of the stages are good. Let's do the final check. We will go to the source code. I can actually see it from here itself. Because the pipeline execution is complete, the Kubernetes manifest is updated with the latest version, and in fact it committed to the repository as well. See the commit. So previously this was the commit ghcr.io. This was the image name. Now it is updated to the latest image name 4757747. What is it? This is the commit ID. So the new Kubernetes version is tagged with this commit ID. If you rerun this, again a commit will be created, but the new commit, the new image will have a different commit ID. You can verify that. Now change something again. Maybe you can update the README file one more time. You will see one more time in the DevOps branch. You have to make change in the DevOps branch, right? Update the README file. You will notice the Kubernetes manifest file will be updated, and from the ghcr.io, the one that we have right now, image. Okay, from this one, everything will remain the same. Only this tag will be updated. This will be updated with the commit ID. Why? That's what we wrote in the GitHub Actions script. In the last lines of the GitHub Actions, that is exactly what we wrote. And this script will remain the same. You might be using Python application, you might be using Java application, anything that you want to, this will remain the same. Perfect. So this is about end-to-end DevSecOps. Now, if you want to complete this, like Abhishek, I want to deploy every latest version onto the Kubernetes cluster, you can also do it. What you will do, just head to the Argo CD documentation. So Argo CD docs. Argo CD is well integrated with GitHub. So every time there is a new commit, Argo CD can automatically identify the commit and deploy that to your Kubernetes cluster. For that, just install Argo CD on the Kubernetes cluster. So what it is doing, I'll explain you that part as well. So GitHub Actions is creating a new image and it is updating the new image in the K8s manifest folder. Argo CD can read it and Argo CD can read it, and what it can do, it can pick up the new Kubernetes manifest version and deploy it to your Kubernetes cluster. This is the capability of Argo CD. So you can build an end-to-end CI/CD process. CI is implemented by GitHub Actions. CD is implemented by Argo CD. What is the bridge between CI and CD? The shell script that we wrote in the last lines of our GitHub Actions file. So this is acting as a bridge. Once all the stages of CI are complete, the shell script is updating the Kubernetes manifest with the latest version. Argo CD looks at that GitHub repository. It will look at the commit like this. So it will keep looking at this file. It will see if the image is updated. Okay, it identified an image change. It will deploy the new images onto the Kubernetes cluster. Right? In our case, onto the EKS cluster. I can show you that as well. So now Argo CD is installed. If you just do kubectl get all -n Argo CD, you will find all the resources that are created in the Argo CD namespace. There will be a bunch of resources, but what you should be interested in, the first one, kubectl get secrets -n Argo CD. You will have something called Argo CD initial admin secret. Just fetch the Argo CD secret from here because you want to connect to Argo CD. kubectl edit secret, name of the secret -n Argo CD. This is in the base64 encoded format. Copy it. I'll close it here and run kubectl, or directly also echo pipe base64 -- decode. Great. So this is the password. Now how to connect to Argo CD? kubectl get svc -n Argo CD. So this is the Argo CD server. kubectl port forward svc Argo CD server. Choose a random port again. We'll this time go with 7111 colon 80 is the service port of Argo CD -n Argo CD -- address 0.0.0.0. Now we will copy the password here. Okay, go back, localhost colon 7111. Oh, my bad. I added one extra one. Now, why are we doing kubectl port forward all the time? Because we are using a free, not free, but we are using an EKS cluster on AWS free tier. if you keep using load balancer or if you keep using ingress, it will incur a lot of cost for you. Instead, kubectl is free of cost. That's why we are going with it. But otherwise, in real time, you have to create an ingress or you have to create gateway API for it. Admin is the username and this is the password, the one that we got from the terminal. Now setting up Argo CD is a cakewalk. Just create a new application. Okay. I'll call this as Jerney application. Name of the project is default. Sync policy is automatic. When you say sync policy is automatic, it will start looking for a repository. Which repository it should look for? This is a repo. Okay. Copy. I'll paste it here. Repository URL. Which path it has to look for? It has to look for the K8s path. Which branch it has to look for? I will say just look for DevOps branch. Okay. Because CI/CD is updating DevOps branch. Cluster URL, go with the local host. Argo CD is installed on EKS cluster. I'm saying just update the same cluster. Namespace, let's say the Jerney namespace. Perfect. This is all. Just click on the create button. Argo CD will automatically sync. It will start deploying all the resources that are in the K8s file. And now if you make a simple change, okay. So right now in the DevOps branch, in the K8s folder, in the Jerney.yaml, let's see what is the version. Image colon. Okay. Right now the image version is 47577. Okay. It starts with 47577. Let's make a simple change. Let's see if our end-to-end DevSecOps CI/CD pipeline process is working as expected. I'll add an empty space, commit changes, commit. Okay. Now automatically CI/CD pipeline should run on the DevOps branch, which is running. It should automatically run all the stages. It should update the Kubernetes manifest and Argo CD should deploy it to the cluster because we enabled automatic sync. But you have to note one thing. It will take 3 minutes of time. The default automatic sync time is 180 seconds. So once the GitHub commit is done, you have to be patient for up to 180 seconds. Okay. Sometimes it might happen pretty fast for you, but otherwise you have to wait for 180 seconds. I waited for 2 to 3 minutes. Now the pipeline is complete in the K8s folder. If you look at image tag, it would not be 7 something like that. Now it is 75DA 1DA and Argo CD. It is already progressing the change. You can see it is creating a new replica set and it is updating the pod version for backend as well as the front end. Right? So this is how end-to-end CI/CD works in the DevSecOps practice. We not only looked at end-to-end CI/CD, but we looked at end-to-end project from DevSecOps point of view. Before I conclude this video, I just want to tell you, at the very first sight, this might look overwhelming to you because I covered everything in one video. Ideally, this should be a playlist where I have to take each and every step and I have to cover each and every step as part of an individual lecture. That's what we did in our Udemy project, right? If you look at my Udemy DevOps project, I took even more complicated project and I explained the same things for 14 hours because I had to go through each and every step and explain it for you. This time we did it in one single lecture. We did it for DevSecOps from security focus. So at the initial site, this might be overwhelming. Please watch the video again if you're stuck at some point, or start looking at the GitHub repository and start implementing on your site. Thank you so much for watching today's video. If possible, please share it with others because videos like this deserves an appreciation. See you all in the next video. Take care.